1 month, but due to design restrictions, we are providing a backup of 10 days. For a day of power outage, we are producing enough energy through the solar grid to run the basic facilities like fans, lights, and pumps. These are the numbers for it. So safety and security as our utmost priority at IES. So while designing, it is taken care that there are no blank spots in the design, which is not under the surveillance, and additional breakouts, drop-off space has been designed so to provide safety to the students.
So good morning, jury. I, Harshil Parekh, come from a civil engineering background. And as we know that the architectural dream is an engineering nightmare. But still our engineering team pulled off and designed in such a way that the structure came at the end is stable. So we had done a stimulation in StatPro software. Where we have considered the load stimulation, where first we have considered live load and the dead load of the structure and how it is well distributed throughout the columns to the pile. Then we have considered the bending moment load distribution, where we have considered wind load and the earthquake load due to as our site comes under the earthquake zone 4 in the strip section. In the strip sections over here, the slab and the beam are connected such a way that the load of the structure is well distributed through the columns. Over here, in the column layout, we have choose 48 columns throughout our structure for proper stability. In this structural elevation, the beams, slabs and columns are designed such a way that the load directly goes to the pile and provides stability to the structure. Dimensions of the column are 500 by 500 and the dimensions of beam is 600 by 300 and slab thickness is 150 mm. In the operation side of the building, we have provided a suggestion of providing two sections for the staircase, where the one section would be going upwards and one section would be used to come downward. This will increase the discipline in the students, at the same time avoid crowding in the staircase. This is a common circuit breaker, where this is used for reducing the power consumption by just switching off one switch which is out of the class. We can switch off all the lights and fans of the in the classroom. And also there is a okay, so this is the VRF system which we have considered. While comparing it to the traditional system, we came up that it reduces almost 40% of electric energy consumption. And also it is costly at first, but while doing the payback analysis, we came up that it is more economically feasible in long run. This is the calculation of VRF. So soil waste management, we have tried to include in the students' curriculum in such a way that they can also understand the importance of soil waste management and get a in-hand learning of it.
So coming to health and well-being, this is a comparison between the comfort level and other dehumidification required, which is the base case. So for the indoor air quality, we are providing fans in the breakout spaces, corridors to purify the air in the interior spaces. For ventilation, we have gone for the strategy of cross ventilation, which is explained above. And along with that, we are providing ventilators on the corridor side to achieve 80% natural ventilation. And low VOC paints are used for internal finishes. Coming to the heating ratio, as we know that the hardscape area gets heated up 2 times faster than the softscape area. So along with the passive strategies, we have provided the softscape area to reduce which reduces the temperature by 4% in the interior spaces. Concluding, annual IMAC chart reads that we are achieving a range of 22 to 27 22 degrees comfort level in the interior spaces, and the pie chart shows the comfort level achieved throughout the months. In embodied carbon, we have tried to lower down the lower down the carbon emissions through transportation and the materials, wherein the graphs shows the comparison between the baseline case and the proposed case, where we have achieved 36% reduction in the carbon emissions.
Yeah, coming to the affordability part, initially the base case design had 33 crores of the budget, but by introducing strategies and different MEP servicing like solar panels, the project the proposed design will be around 36 crores. That will increase to 5.9% of it. After capex and life cost analysis, the major energy that we are saving is from solar panels, and by using MEP savings, that is from terracotta jalis and reflecting sliders. For the value proposition, we were provided with the project plan of the project partner. We analyzed that plan with different simulations, and there was a result that we ticked on to all these parameters from lower heat gain to resilient. All these parameters are more like properly achieved in our design than the base case. Thank you. So I would like to show you a demonstration on this model. So this is the north side of the classrooms, and this is the south side of the classrooms. Since we have maximum radiation from the south, this is the base case. This parapet wall is the base case, but we have introduced terracotta jali that will distribute the radiation inside the corridors. That will also minimize the heat gain, and the corridors will be used for different purposes. The partition walls that are between are used by polyurethane foam, and here you can see the light shells that we have added that will increase the amount of daylighting into the classrooms. Yeah, thank you.
Can you show the reflective light? Jaldi reflective.
Also, these are the reflective panels that we have added on the sliding window. Thank you.
Thank you, team. You finished well in time. Let's hear the jury comments and take questions from them.
How much time do we have? For 10 minutes. All right. So, firstly, thank you very much. I'm going to give you some comments, generally feeling about the presentation, and then just a couple of questions. So I think what I really liked is the fact that you are trying to get hands-on with simulation tools as well as physical models. You're trying to understand, how building physics behaves, how light behaves, things like that. And there are many things you're trying to tackle at once. So that's very good. Now, coming to your design, I think one of the issues I raised to you in the questions as well is about the percentage of building that you have assumed to be non-air conditioned, right? So I imagine something like about 22% is only conditioned, the rest is all of it is, so let's say 80% of it is not air conditioned. So could you, I'll pose two questions and then you go for both of them. The first is, can you tell me how your building is going to give more comfort to a child in this space than any other conventional school, right? Because they also have open windows, and maybe larger ones than you. So how have you kind of proved that? Second is that I feel that your terracotta exploration is very nice, as an idea, but you've not reached the point where you've actually identified areas which actually require it and not require it. I'll pose a question to you. You showed me this demonstration, but as soon as you put these, you're going to decrease daylight, that's entering from the other side, right? So have you studied it? Have you done a simulation? You've seen that, by adding those terracotta jalis, you are actually decreasing the daylight, which is very important in the rooms, or not? And when you add those terracotta jalis, for example, if you look here in this image, that you have in your render. Could you open a render of your? So I'm just wrapping up my, just the corner, this main render that you're showing me. Yes. So, even from this image, you can almost see that, there is no logic to why certain areas have terracotta jalis and others don't. Right? For example, all the lower portions have a lot of terracotta jalis, and suddenly in the middle you don't have much. then you have a lot. So this is not connected to any, kind of presence of solar radiation or not, right? Or daylight or not. So I think your analysis has to reach to that level where, generally in a building like this, I would expect, that you would have much more of it on the top, right? Simply because you're more exposed to sun on the top and then the lower area. So these two questions, comfort, I think you're not providing adequate comfort levels. Can you counter that? And second is, why have you taken such a random pattern? While you're saying you're making it very science-based.
Yeah. So I would like to add on that firstly we have designed this terracotta jalis in according to the user group zoning. So on the higher floors we have different like the spaces are not utilized throughout the day, and on the bottommost part the spaces are utilized throughout the day, and the patterns which are increasing here will ensure that the breakthrough spaces that are in between the corridors will ensure that the maximum light entering is from the north side and not the sunlight, whereas the corridors that are happening over here will also have the sunlight exposure, so that will not reduce the daylight amount. And after simulations also we realized that yeah, there is a little amount of daylight that is reducing, and because of that we have added reflecting sliders that is on the northern side, so the daylight factor is covered through that. Yeah, and the other question that you asked was about
80% of your
80%.
building being, so all your students essentially don't have any additional, according to me, you can challenge me, additional comfort in terms of humidity control and all that, right? And your VRF system, also you're not mentioned any, humidity control or fresh air system that actually goes to that. So how are you doing that? Explain a bit more about the comfort, levels.
Okay. So like majorly comfort, we are achieving it through the windows that are the ventilated windows that are there on the corridors. So that will ensure that we have analyzed the positive and negative pressures that is acting on the southern side and the in between the corridors. So because of the negative and positive pressure, there is maximum amount of airflow that is happening.
What happens on a still day? It's not windy. What happens? Do you think you're going to have enough, ventilation, and then air from outside is going to be humid anyway? Monsoon,
Humid.
80% humidity. Can you, provide the comfort?
Yeah, but like humidity is being controlled by the terracotta that will absorb much amount of humidity.
So very romantic and very nice idea, at a small scale. But maybe for a large building, it doesn't have the capacity to handle that. So I think you need to kind of explore how you manage the comfort of the students a bit more.
Okay.
And I'm going to give it to you.
Thank you, sir.
So, I mean, good job, team. I think it's a good work and a lot of hard work that you've put in. I think these terracotta tiles are one of the key features of your project that can be easily seen here. So again, my question would be, in addition to this, anything that you put on the envelope would have a dual impact. It's going to be with respect to your cooling consumption, because you're heating, you're basically like putting like a layer between your main envelope and this one. So there's some sort of optimization that you need to do with respect to your heat gains and the daylight. So even the point would be, since these are classrooms, again, the daylight becomes very important. But again, you have a few spaces which are also air conditioned. In looking at this, I cannot spot which all are the air conditioned spaces. Maybe it will be also worthwhile to look at what is the impact of these terracotta panels on the air conditioning loads. I can see in your report that you have done like an incremental analysis of strategies, like there is a reduction of 5% because of shading. Then maybe I can see there's some 15% because of envelope. I don't know where would this strategy fall into. And because of this, how much of energy reduction are you achieving? So that can also be a point. And plus, even the position of these should be dependent on the climate analysis in general. One point, as you're rightly saying, okay, south side would receive a lot of radiation, but it would be great if you would have like taken a step ahead and then designed these in a better way so that it's even aesthetically appealing, plus it's also performing as you're intending it to be. So that's one comment. And my, so maybe would you want to answer that? Then I can.
Yeah, actually, the major spaces that require HVAC are placed on the northern side. So the amount of radiation falling on that part of the building is very less, and that will also reduce the consumption of the AC that we need to the temperature that we are maintaining here. and we chose the classrooms to be there on the south side, since the maximum radiation will be obstructed by the terracotta jalis. But the main idea was to understand the circulation pattern, the wind circulation that will be carried out on the south and the western side. Since our site is very nearby to the creek, the winds are entering from all the directions throughout the day, and that was the reason we placed it on the southern side, not on the northern side.
Because it would also be a little counterintuitive, because the south side is receiving a lot of heat and the classes are also non-air conditioned, so that's something that you need to pay attention to. And my second point was more on the polyurethane foam partitions that you are providing between the classrooms. I think it's also important to consider the part of acoustics or the sound transmission. You need to make sure that, because of what's the thickness of these panels?
The polyurethane foam is 120 and the glass wools is 20 The panel is out of that. So basically, the glass will absorb major amount of sound, and that is the sound barrier that we have.
So it's a total of 120
Yeah,
mm
yeah,
thick
150
wall.
mm.
Okay. Because that's also one thing that is very critical in school buildings when you have classrooms stacked together.
Yeah.
That's one property that again you need to look for and benchmark it against the conventionally available partition walls. Is it standing up to the requirement? And the concept of, again, the absorption and isolation are very different. But then you can try and understand it from that perspective as well.
Yes.
Answering the energy reduction part, so because of the reflectors that we are using, we are giving reflected light to the classroom. So the base case and the design case that I explained. So we had done stimulations on both the sides, whereas on the base case, where we had the corridors that we are talking about on the northern side, and that reflectors on the southern side. And we did did it in the opposite way, where the design case has a corridor on the southern side and the reflectors on the northern side. So because of that, we already are increasing the amount of daylight. So we can see the useful illuminance that we are increasing through that. So that's why there's a reduction in the amount of artificial light that we require. So rather than using light for like 9 hours a day, we are using it only for 5 hours a day. So that is one of the major reduction throughout the year that we are having. Yeah. So the thing is that, the terracotta jali are on the southern side. So that's what we did. The reflector windows were given on the northern side to get in the northern light, reflected northern light.
This would be a little questionable, because in your simulations, I'm not sure, have you considered the entire direction? I think this classroom is completely open from the outside.
Yeah.
But in here, that's not the case. Like your building is C-shaped, so
So as you said that the major problem is on the southern facade. So we analyzed these on the southern facade itself. Rest of the side will eventually have the proper wind circulation and daylight through all the surroundings, because it is not obstructed by any buildings around it. That was the main idea, that we had to simulate the southern side more.
Let me also ask you this question, because I'm in kind of continuation of the questions that are coming on the building envelope and also on the polyurethane. So you mentioned in the innovation part that you are proposing that material, otherwise it would end up in a landfill. Am I right?
Yeah.
I didn't understand that. If you're not using it, I mean, why would it end up in a landfill if you're not using it?
So basically, the material is upcycled, and since it is not decomposable in the landfill, the manufacturers that are nearby to the site will majorly give us the polyurethane foam in a proper amount of sizes. So yeah, that is the main purpose, that because of that we reduce the landfill.
So you're saying that you're upcycling the material, so that's hence you're using that. Okay, got it. Now on the building envelope trend, I mean, it's exactly what I think all the three of us were concerned about. One, summarizing, what you used on the south, had the geometry been, in summary, what we're trying to say is, had it been analyzed, even given the shapes, the punctures and everything that you gave, had it been an outcome of an analysis, it would have been nicer, because right now it's more probably intuitive what you did and trying to then justify that intuition rather. That's number one. And the second thing, your site is otherwise a perfectly north-south oriented. It's a square. And then you kind of pasted and made it into a chamfer and gave a facade.
Yeah.
Right? And you opened the courtyard towards the west.
Yes.
Correct?
Yes.
Had you done any analysis to check exactly the opposite, where you flip the form and you're cutting the western that's coming and also the south sun, and early morning the eastern sun that is there, had the courtyard been on the other side?
Yeah.
Just a mirror of this. Have you done this?
Actually, we after analyzing the context, so exactly beside the site on the eastern side, we have a school itself, which is a 6th floor high. So that is also blocking the sunlight that is entering from the eastern side, and also it blocks the winds. So that is why we decided to keep it on the western side. And since we have playground on the opposite side, so that will not obstruct the winds that are coming in. So the
Okay.
experience will.
So you
be
considered that. That's good. So now talking about, so now you visited the form.
Yeah.
And you have given it an angle. And your windows, especially because that's a very important feature that you are talking about even in here in the model. And it's actually good to see the study model that you're presenting here. Have you done analysis only on the section of the window? Currently it is parallel, right?
Yeah.
But you twisted at an angle. It would
Okay.
have been nicer in actually designing the shading device and also the light, and had the reflector been part of the on the vertical face, so that from the western side the sun, which is coming at an angle, is actually reflecting inside. So have you done any kind of design analysis to understand the shape that you have given, so which would have helped actually amplifying the light inside? Or is it just whatever I mean, basically you made it as a parallel line, offsetted. I was asking why not at an angle to get the light inside?
So like if we add parallel pins or the parallel reflectors, the sun which is setting down on the western side will reflect the sun rays, and the sun rays will try to enter the classrooms, and that is why we kept it
Sorry,
horizontal.
I'm talking about the shading being parallel.
Okay.
Not reflectors is the next one.
Okay. Okay.
So you're saying that it's at an angle right now.
Yeah.
So had the shading been at an angle, the shading device, which is the chaja that you gave on the top, so that to understand, because you are opening it towards the west, so that have you done any analysis to see how much west you're blocking and what's the optimum amount of shading that you're getting as a vertical shade? If you look at the model, I'm talking about the vertical member.
This member.
Yes, that members that
Okay.
are there, and also the depth of that. Because right now, had it been perfect north, perfect south, or west, it makes sense. But you're making it an angle. Was there any form of analysis done to determine the shape of the overhang?
So we decided the sizes of the chajjas to in accordance to the rainfall that is falling. So the aesthetic part was not like added to this because
Not aesthetic. I'm talking from the shading and
shading
also the
and
sunlight
yeah.
perspective.
It was not added to because we had to keep it more simpler than adding that angles.
Yeah, I think that's from my side also.
I just wanted to continue something that I had asked you earlier. You mentioned about the comfort. You had shown some pie charts about comfort. Could you bring them up? And secondly, I think the person who discussed the VRF system, like, could you explain how you supply fresh air? Like, that means outside air to that system.
So, with the strategies, the indoor air quality and also the hardscape and softscape ratio, we are achieving the comfort level as seen in the pie charts.
Can you explain it? Like, dark blue is comfort.
The comfort level, and the lighter shade of the blue is the dehumidification that would be required still after achieving this much amount of comfort in the design. So that dehumidification.
Something confusing about them, because you would need to dehumidify to get that comfort.
Right, but providing the strategies, this is the amount.
Chart. So there is something wrong. Have a look at it.
Yeah.
I think there's another pie chart, I think, for comfort somewhere you had shown, which you moved very fast, so I couldn't see it. Yeah, this one.
Yeah. This was the base case to show that this is the comfort we have right now, and the amount we need to dehumidify through the strategies. Yes. No, the percentage through comfort percentage throughout the months.
So in monsoon, you're saying May, June, July, August, September, 64% are not comfortable because you need to dehumidify. Correct? Okay. So the label is not comfortable. So yes, that's the point I was making, that if you go with any of the standards, you will find that. That makes sense to me. So that's the huge challenge you have. You need to find a way to dehumidify, or at least supply some fresh air, which is dehumidified just for those months. So you could have thought of another system, which was just, kind of a air-based system, which is activated only for the monsoon months, supplying dehumidification.
Yes, yes.
No coolant.
Yeah.
So something like that could have been done.
Definitely.
And the answer for the VRF, you have a diagram, It's very important because, these things are what you need to improve in your project as you go forward.
So sir, we are going...
There was a diagram about the air conditioning system. See, these are labs, right? So you need a lot of fresh air from outside coming in. How does that happen in the system?
So sir, we use the VRF system in such a way, like it is a hybrid model where it is connected to a common connection is given, where the air will flow, and as we set a temperature, let's take for example in a class, in physics lab, we choose to keep it at 25 degrees Celsius. And in the storeroom, if we want, we can keep 20 degrees if we kept stuff like that. So the system is designed in such a way that it will segregate both the class, and after giving 25 degrees Celsius, maintaining a 25 degrees Celsius in physics lab, the extra wind will flow towards the storeroom, and then we'll have a system which will cooler it and make over the 20 degrees Celsius. Your fresh air point was that we can we need to provide an extra.
Presently, so just for clarity of everybody, presently your system does not supply any fresh air to the labs when the system is running. You'll have to open your window and keep your air conditioner running to get any oxygen in. So there is something you need to resolve.
We need to rectify that.
Right. And as soon as you do that, your energy numbers will go boom up, right? Because you'll have to do many things. All right. So you got my point, right?
Yeah. Yes, sir. We need to rectify.
Great effort. Thank you very much.
Okay. Thank you, sir.
Thank you so much.
Thank you, jury members. Thank you, Team Austenite. And let's begin with our second presentation. Our second presentation is from Team Aurum, BMSCA CA. They have worked on a RAISE primary and high school, which is located in Bangalore, and their project partner is RAISE Academy for Learning. Team, you will have 20 minutes to present your work to the jury. At 15 minutes, I will ring a signal like this. You won't have a 21st minute, which means at 20 minutes, I will stop you and ask you to end your presentation. After that, we will have 10 minutes of Q&A. Please keep your answers direct and to the point. So now the stage is yours. All the best.
Good morning to the jury and everyone present here. My name is Shena and I'm the team lead for Team Aurum. We are from BMS College of Architecture and BMS College of Engineering from Baswangudi in Bangalore. Today with me I have Niharika, Raksha and Aziz, and we're going to be presenting our solutions for our project partner, which is Raise Academy for Learning, situated in Bangalore, Karnataka.
We as a team here are with the proposal for redefining learning spaces and harmonizing design, technology and environment for our project partner. So our team here, as you can see, consists of students from multidisciplinary backgrounds, namely architecture, engineering streams such as civil, mechanical and aeronautical. We have our faculty lead with us, that is Dr. Suhas, Assistant Professor, BMSCE, and Faculty Advisor Shubhra Pandey, Associate Professor, BMSCE. We have collaborated with industry partners, one, that is Studio Kinza, an architecture firm who guided us throughout the project, and two, EcoSoch, our solar energy partners. So introducing our site, it is located in Karnataka, specifically South Bangalore zone, in a temperate climatic zone, and in Uttralli, near Vasantpura. So our site, you can see, it's divided into two phases, where phase 1 is dedicated for the program of school construction and phase 2 for future expansion. As you can see in the picture here, the site consists of dense vegetation of coconut trees and mango trees. Our site is spread over 6 acres. Here you can see that it is located within a residential zone with few dispersed commercial areas, and access to our site is through the road at the north of the site.
So our design proposal included the following goals and strategies. So we aim to be net positive in water and energy design, and we aimed to reduce our carbon emissions by 45% compared to the standard. Through our innovation, technology, engineering, operations, and architectural design, we aim to provide an efficient building which will be based mainly on passive cooling in order to reduce the mechanical load on our building. We aim to be cost effective and also gain returns. The details of these will be explained in the further slides. So our architectural design process began with mapping of trees on our site and integrating the build form with respect to the coconut trees, which was one of the unique points of our site. So we made sure to be sensitive to the trees as well as the topography. So our strategy was, according to the standards, we left about 2-meter radius around the root of the trees, so we do not harm them during the construction of the building and its foundation. Apart from massing according to the trees, we also placed our build forms in accordance with the sun and wind. The form development began with the tree density, and the blocks were placed in accordance with the trees. Further on, the masses were split according to their functions, and then we established inward-looking courtyards and porous floor plates. So the zoning was done in accordance with the hierarchy of spaces, that is public, semi-public and private. At the entrance towards the northwest, we have the admin block, which is followed by the semi-public realm that has the extracurricular activities and the labs. The classroom block is divided into 2 parts, that is one is for the primary school and the high school respectively. The massing involved the main strategy of splitting the blocks in accordance with the trees and creating internal courtyards to sort of achieve integration with nature, which was one of the major requirements from our clients. And also organization of built and unbuilt spaces was done in such a way that we create voids in order to get maximum daylight and ventilation through passive techniques. So we can see that the resultant massing incorporates the following thing, where we get maximum natural light from the northern and eastern side by the placement of our blocks, and also utilizing the southwest prevailing winds, which is capitalizing on our courtyard effect, which is seen by the placement of our blocks. These figures show the passive ventilation, which is working through the entire classroom and the admin block, which is providing thermal comfort.
Coming to the master plan, so our total build area was 6,170 meters square, and we're catering to 1,100 students. So overall, we have 36 classrooms that are arranged between 2 classroom blocks, classroom block 1 and 2. As shown in the plan, the main entrance to the site is from the north, and you enter through a stilted semi-open space which forms the ground floor of classroom block 1. This space is basically a shaded space that has a waiting area and seating for parents to come and pick up their children after the school hours. And this space is also laid with piezo tiles or piezoelectric energy generation tiles. So our classroom block 1 is a G+4 structure that has 27 classrooms, and the remaining classrooms are incorporated in classroom block 2. Overall, between the classroom block 1 and 2, we have the central lawn, which is the central open space over which all the blocks overlook, and it's into this space that all of the students can spill out and interact with each other as well as the surrounding. And also the students are encouraged to engage with nature and to further plant more trees and plants in the dedicated farming zones towards the east of the site. This was another thing that was sort of requested from our client side. Moving on to our classroom blocks. So this is one of the classroom blocks, which is classroom block 1, which is a G+4 structure. The classrooms are an 8x8 meter classroom, and it accommodates 30 students. The block is oriented according to the prevailing wind direction, and each classroom also has an exterior deck, which is an outward looking balcony. So these balconies sort of provide an external space where the students can come out, interact, and it's also used as an informal learning space. The roof spaces have been dedicated for renewable energy generation from solar panels, and also we've incorporated strategies such as green roofs on the roofs to reduce the internal heat gains coming into the building through the roof. Further, some of our design elements include kinetic louvered panels. So these louvered panels are colorful panels that adjust according to the light and ventilation coming into the classrooms. And the colorful aspect also adds an aesthetic element to the design. We have terracotta jali screens that are placed across our external balconies and also around the staircases. So this sort of brings in cool air movement within the building, and it also creates an interesting light and shadow effect to increase the aesthetic value in the space. Overall, we have the central courtyard space and these central balconies which are curved, so the students can overlook the central space, and there's overall a more cohesive and interactive learning experience throughout the campus. This longitudinal section across the site sort of shows how our design is catering to the existing topography of the site, and how we've also preserved the coconut trees in as many spaces as possible, cutting as less trees as possible and integrating them into the design. You can see this, the semi-open stilted entry space, the G+4 classroom block 1, G+3 classroom block 2, and the central lawn space in between. The further sections show the different blocks and the relationship between the different functions that were zoned out in terms of the private, public, and semi-public spaces. And overall, we've tried to establish very strong visual connects between all of the blocks as we created an inward-looking campus. So this visual connect is established between the different blocks, the different levels of the blocks as well. Moving on to energy performance. So like mentioned, our site lies in Bangalore, which is in the temperate climatic zone. And for an educational building in the temperate climatic zone, the Griha benchmark was given as 75 kilowatt hour per square meter. So that was set as our benchmark, and we set a target API for ourselves as 33 kilowatt hour per square meter. So through various different strategies like passive design, so the massing and the block orientation and our staggered courts and the natural shading and ventilation, through envelope optimization of the roof, walls, and window systems, jali screens, and our vegetative roof, through using efficient lighting fixtures and efficient equipment, and lastly, through the production of renewable energy through solar panels and PaveGen. PaveGen, which is the piezoelectric energy generating tiles, we have reduced our EPI and we got this through a design builder simulation, wherein we were able to not only achieve our target, but also become a net positive building. So now we're producing more energy than we are consuming. Further simulations done like radiation simulation helped us make more informed design decisions in terms of our internal heat gains and what would provide the most comfort to our students. Coming to our envelope optimization, so we compared the envelope to a standard case to choose the most appropriate materials for our design. So we've used cellular lightweight concrete blocks, which is CLC blocks, and this has a much lower U value than the standard burnt brick. So this was used for our wall systems. Our roof systems, we have 3 roof systems. One is an RCC slab with underdeck puff insulation. We also have an RCC filler slab, and so this filler slab is not only reducing the amount of RCC use, but it also makes use of the abundant coconut shells present on site. So this is one of our strategies. And the last one is the vegetative roof. And for our windows, we used a vertical sealed double glazed window. So this has a lower solar heat gain capacity, which reduces the internal heat gains into the building. Overall, through solar energy and the piezoelectric tiles, we are generating more energy than we are consuming on site.
So to better understand the water consumption and to have like better efficient water performance, we curated a table which has consumption of water as domestic use and percentage of water used for irrigation. And also we noted down water sources through rainwater harvesting and treated grey water. So this table helped us to calculate the capacity of the tanks, that is the overhead tank with 10,000 liter capacity and the underground tanks for 30,000 liter capacity. So here the diagram explains how the portable overhead tank provides water to various different spaces, and from here grey water is collected and treated. And this is sent to various activities like irrigation, toilet flushes, and green balconies. Further from here, black water is collected and pumped into the municipal sewage system. Through this diagram, we also understood that reducers are very effective in our system, catering to the user group that are children to control water flow, pressure, and consumption. So here this table clearly explains as it compares total consumption of water without reducers and with reducers. So the usage is reduced by 32%. In grey water treatment procedure, we have an intervention where coconut husk is used as a filter. So the problem we identified here was various chemicals when used for grey water treatment in a long-term run affects the health and well-being of the children as our primary user group. So what we did was we used coconut husk fibers, which function is to like screen out large solids during the filtration process. And these fibers are weaved together in a tight mesh pattern, and several layers are organized to ensure efficient filtration. And these layers are replaced every 6 months.
So moving on to embodied carbon, there's two main factors that contribute to the emissions. These are material emissions and transport emissions. So comparing over a standard case, we were able to choose appropriate materials for our wall systems, roof systems, and the windows to overall reduce the emissions of our building. So talking about material emissions, compared to a standard burnt brick building, we've used CLC blocks, which has a much lower emissions factor. So we were able to reduce our wall emissions. And CLC blocks also have a lot of other sound insulating, fire resistant, thermal insulation properties, which made it an appropriate choice for our building. Coming to the transport emissions, so like mentioned earlier, one of the roof systems that we're using is a filler slab. So these use the shells on site. So this addresses the transport emissions where we're making use of the abundance of the coconut shells on site. And a filler slab also uses less reinforced concrete than a normal RCC slab. So in this way, we were able to overall reduce the emissions from the base case to our proposed case of the carbon emissions from our building.
For the resilient approach, we had three main categories. So for the natural calamities, we treated that with an elevated plinth and valves, which prevent the backflow of drains, and also to provide an RCC frame structure, which provides support against strong winds. With respect to the building performance, we have provided with passive cooling technologies and are insulating CLC blocks, as well as treating grey water. With respect to unforeseen disasters such as power cuts, we have 2 diesel generators. And with respect to firefighting strategies, these CLC blocks have a rating of 4 hours without emitting any toxic fumes. So with respect to the days of autonomy of water, if there's consumption of only potable water, then it will be approximately 7 days. And with overall complete water usage, it will be 5 days. And the days of autonomy for electricity will be 1 day while using 2 diesel generators.
So moving on with engineering and operations, considering our goals of implementing efficient engineering techniques, as well as reducing the mechanical loads on the structure, we have gone to some research and have ended up with some strategies which actually reduce the internal loads up to 70.6%. So we took an example of a building near to us and of similar size and calculated their mechanical loads in the BTU units per hour. And then we have actually categorized that into 5 parts as envelope, equipment, lights, people, and fresh air. So when we proposed our design, we took off some strategies which also included changes of materials for both walls and the windows. The strategies which we used CLC blocks for optimizing the envelope, which has better, which has excellent thermal insulation, as well as very lower U values. And when moving on with HVAC, most of the areas of our education building is basically naturally ventilated. So a heavy design of ventilation was not required. But on the request of our project partner, we have introduced ACs in 3 spaces. Basically the admin offices, computer labs, as well as auditorium. And our HVAC system is basically inverted ducted central air conditioning system. It is highly efficient and is 5-star rated by BEE, and it also has BMS control software through which we can actually optimize the time considering our needs. Considering the basic structure of our thing, we have, as normally everyone use, we have used 3 types of columns and 2 beams of these dimensions, and the spans which they cover are basic to the educational and co-curricular buildings. And when we come to solid waste management, we basically categorize it into biodegradable and non-biodegradable waste. The biodegradable waste which we have, we use it for composting, and which actually produce manure, and we use it for on-site organic farming. And a non-biodegradable is basically sent to the recycling stores, where they recycle it and give it back to the market.
So coming to the affordability, this chart shows the comparison of the base case and the proposed case. It shows where our project cost is about 41 crores, and the increase in this is mainly shown in the MEP, that because of the renewable sources of energy that we are using, and also that we're and also we're obtaining returns over a long term. This shows the timeline of the different construction stages, which is spread across like 1.5 years.
So for innovation, we have 2 interventions. The first one is integrating artificial intelligence with building management systems. So this is done in existing, in areas when noticed like multiple security roles is like diluted merely into like software procedures. So for example, like cameras can be installed which detect motions of like the students, which can reduce the manpower implemented for the security reasons. And it also helps in automatic updation of like logistics and maintenance, and also like integration of personalized lesson plans for the students, for like, and also arranging meetings, scheduling for and updating parents. The second intervention is like producing paper with coconut husk and also recycling paper. So we propose this as we identified the problem being 2,000 sheets of papers are used per day, which leads to felling of 50,000 trees at one go. So we proposed this of using coconut husk in the process of making paper, and this process involves several stages. So hence students can be involved in this process, which aligns with the concept and ideology of a partner.
Moving on to the health and well-being. So our site lies in Bangalore, which is in the temperate climate zone, and we carried out a yearly temperature comfort analysis, wherein we looked at the outdoor temperatures for the operative hours of our school. We defined the operative hours of our school as 8 a.m. to 4 p.m. So through this, we were able to sort of determine the times of the day which are lying in the warm zone, the comfort zone, and the cool or cold zone. And 47% of the hours is in the comfort range, 12.5 is below the comfort range, and 40% of it lies in the warm range. And we've tackled this through our passive design strategies, and owing to the fact that the microclimate of our site is lesser due to the abundance of trees. Coming to the light and ventilation, so our aim was to bring in ample light and ventilation into our classrooms, natural light being very important for the education of students. So we've provided the orientation and the placement of the classrooms to receive maximum natural light through the windows. And also each classroom is designed to receive cross ventilation throughout. We ran a simulation on our building to check our operative temperatures and make sure that we are lying within the comfort range. So through this, we adopted the comfort model of ASHRAE standards for the temperate climate zone. And in this, through the simulation, we were able to achieve a comfort range in temperature and humidity for the operating months of the year for our school.
So coming to the value proposition, so we have successfully been able to
Sorry team, the time is done. Thank you team. You did a great job, and let's hear the jury comments and take questions from them.
So is this better? Can you all hear me now? Okay, I'll keep it close. So thank you very much. Further? Okay, this is all right. Nice presentation. I think it's a very interesting project, especially because of the site. And it's a huge site. You're building only part of it. And there is so much you have done, and there is so much more you could have done. So there are so many ideas as an architect that come into my mind on my own. So what I'll do is I'll just pose a couple of questions which I couldn't really get through, and then you can respond to them. So some of them I see you've answered right already, so that's well done on that. I still, I'll start with this. I saw that, in the report, there was this lake, which was somewhere on the southeast side. So one of the things in my mind was that your planning of the water system, right, water management, how does it connect to the lake, right? Because these are generally all integrated systems, regionally, right? And your site is a huge part that actually used to feed the lake. Have you thought about that? How do you keep the lake alive, and what have you done? Because there's nothing in the report. So I'm hoping you've done some more thinking on that. Second is that I saw that your construction rate, per square foot is 400, something like you. Did you mention? 400 rupees a square foot? Or did I get it wrong? Here, 457, bottom right. So last column, bottom row. 400, is it 457 rupees a square foot of construction? No, total, this is total? No. Okay, so if you tell me the per square foot rate of the full building that you have, except land or whatever. 8,400 something. Includes the land. Okay, and the land is 2,000. So you are building at, say, roughly about 6,400.
Yeah.
6,400. Okay, so that is a very expensive building according to my numbers. Why is it that? Because everything you tell me is about low cost using
No, so the strategies that we try to incorporate, like with this site, that's the coconut thing, or all the passive design strategies, is like those. But when we went to address the MEP, the mechanical services, that's when we have catered to using of these solar panels with our the industry partner, that is EcoSoch, and also the piezoelectric tiles that we're using. So that's where we're getting costs. So our justification mainly goes like in the value proposition, where we try to state how our case, that's the blue line, becomes net positive over time. Initial capital costs is high. That's what we have also proposed here. So this is like of expenditure versus years of the base case, and versus the red line is the base case and the blue is our case. So what happens is that in 2026, the case 1, we attain correspondence with our proposal, and at 2029 is where we achieve break-even point. So we do have initial high capital costs, but over time these just get compounding, and like our returns become more. We're also sending back to the grid because we're generating more than we're consuming. So because of this equipment that you're using, our initial capital costs are high, but this is our justification as to how it's going to be sustainable in the long term.
Okay, all right. I get your point, what you're saying. Still, just you can have a look at 6,500. Maybe it's the, this piezoelectric tiles, right? I mean, one of the questions I'd posed to you was that it appears, did you relook the numbers? And how much percentage of your energy is coming from piezoelectric?
It's not square feet. The cost is not per square feet, it's per square meter. So it's only 800 rupees. Can you go back to the costing sheet, please? So the next slide. So including the land, the cost per square feet is approximately 800 rupees per square feet.
No, we did square meters, like.
8,469 by 10.764. It's approximately 800 rupees per square feet, including the land cost.
Yeah, including the land cost, yeah.
That's extremely low. It's way too off. It's way too off by miles, including all the MEP, the land, the services, the solar panels, everything that you're doing, including the land cost, 800 rupees per square feet. You can't even do the civil in today's date, civil work.
Yeah, we'll relook at the.
Relook at the numbers.
Yeah.
I mean, they shouldn't be so off, but
Okay.
something is going on. I think about it. Now, I'm going to just leave you with one question, which I wanted clarity in. You mentioned, that you went for some expensive systems and blah, blah, blah. So I'm just continuing with that idea. HVAC system, I believe only, 500 square meters of your 5,000 square meters are actually air conditioned. So my question to you is, why does an admin officer in your school need AC and other people don't?
So this was something that we sort of went back and forth with our project partner as well. Our main aim was to make the entire thing naturally ventilated to reduce that whole mechanical load from the AC. But their particular request to us was, let's keep our admin offices air conditioned, let's keep our auditorium air conditioned because the type of equipment that's going to be used there, and let's keep our computer lab air conditioned due to the heat, like the heat generated from all of the equipment. So we took it upon ourselves to justify that all of the classrooms can be naturally ventilated, and we're going to stick with that. But based on their request, we have introduced AC in those 3 spaces particularly.
I'll not re-question on that, but just answer the water lake question that I gave you.
Yeah, so currently the lake is not utilized, and like government is still proposing like to rejuvenate it and all. So as in when we saw like the rainwater being harvested and grey water treated with going according to the norms that we can allow the after it satisfies the consumption of the school, we can allow it to go to the lake according to following the rules and regulations by the government.
I think it's a bit of a miss because, your lake is actually natural. It's part of the natural system. Water from this actually feeds the lake. Right? Right now you're saying you're going to take a lot of the water, but you're really not thinking that is there any treated water or natural water that goes into it. Something to think about for the future. Let's leave it at that. We're running short on time.
No, we didn't mention that we're going to use the water from that.
No, but you're using on site, right? How do lakes form?
Yeah, sure.
All the surrounding lands, they contribute water, right? So now big chunk of land is not contributing to the lake. So the lake will eventually, be deficient in water. You need to balance out. You need to think about sustainability.
Yeah, so it's currently underutilized, and as I said, the government is proposing for rejuvenating and so that the lake is redeveloped. So as in when we meet our consumption and we see that we reduce our usage and consumption, so we'll have efficient water, and we have storage tanks with a good capacity also. So once we reach that level after rainwater harvesting and treating grey water, which meets the standards of the clean water that can be left to the lake, we'll eventually follow that.
Sure, we can talk a bit more after this.
Sure.
So I had a question on your, there is an annual simulation result which is shown in one of the slides. So if you can just go on to that. And one thing that you mentioned is that you're able to keep the spaces under comfort band during the occupied hours. But one thing is that it will be always, it's always good to highlight what are the occupied hours in that entire year. That's one thing. The second is that for which space are you actually showing that results for? Like which classroom is it exactly?
So these apply to both the classroom blocks, like in.
Yes, this one.
Yeah, so this applies to the classroom blocks, classroom block 1 and 2, which were placed accordingly.
Okay, and you're saying for the entire month of April, May, and June, all 3 months will be off?
Yeah, so during the operating hours of the year, operating months of the year, we're within the comfort band. During the peak summer months, we are slightly off, but due to the microclimate of our site, due to the abundance of the trees, we and due to all of the passive strategies that we've kept and all of the envelope optimization that we've sort of addressed, we aim to reduce that even further and make it comfortable throughout. But currently, this is the operating temperature of our school. So for the operating months of the year, we're in the comfort band for temperature and humidity. Yeah, academic calendar from April, May is your summer holidays.
Okay, because if you see in the month of June as well, there are many, I'm sure there will be a lot of occupied hours which are going, I think it's hitting around 32 degrees. And like if you're making the students sit in such a warm kind of environment, that's something that you need to consider again.
So another thing is when we were running the simulation, we were, like the microclimate of the site was not being considered in that because the abundance of trees on site is really, it has a big impact. And because of all the staggered courts and the external balconies that we've provided, there is a very big passive impact in terms of that climate to reduce it to the classrooms, which through the simulation, like that was not really being considered.
Why do you say it's not?
So as we ran the simulation,
Where is your weather file location?
in Bangalore, South
It's
Bangalore.
at an airport, open site, next to the tree. It's going to be very simple. Just arguing
Yeah,
it out.
you should consider that because the design, whenever you design, you need to design it for the worst case. Like you cannot assume that the building will behave in a way or the people will be comfortable by default. So consider it in the coming times. And the second question is, I'm curious to know why have you used a VRF system in the base case? It's already a very efficient system.
That's the project partner's
requirement.
case.
So they had suggested to use that as a base case.
Yeah, that's what they are.
And in fact, even the strategy that you're proposing, which is the Blue Star ducted system, just read a bit more about it. That in itself is also using a VRF system. Read a bit more about that. Okay, so that kind of comparison you need to do, understand the systems in a better way, and then try to see how can you simulate it.
Okay. So the reason we chose that inverter ducted technology is because inverter technology firstly is very energy efficient, wherein you're able to regulate the temperatures.
VRF systems also use inverter compressors to kind of regulate the flow of the refrigerant. So that's why, I mean, just take a, yeah.
Can you go back to the site plan, please, with the where you have the Google Map image of the?
I'm so sorry. Just to add to that, the refrigerant as well that we're proposing is a different refrigerant because the R410A is going to phase out. Yeah. So we're proposing, multi-cool, which is
back. Google Map image. One more back where the trees, this one, phase 1, phase 2. So in this case, if you look at the trees that are, it's quite densely planted, right? So I'm really afraid, I mean, the blocks that you're doing, it would have been nice had you actually overlaid the blocks on this. And also the orientation that you have taken currently, I really doubt because most of the blocks are actually facing east and south, east and west, the orientation of the south walls. So just, wondering whether you have actually considered this density in your planning. And the bottom part which is empty, so that's not yours, is it?
No, that's
not yours.
left.
So I mean, this and the master plan that you gave, in that the number of trees that you considered in that is very low, at least in the site plan. Go next. Yeah, it's. So are you cutting a lot of trees? Yeah, this one. Look at this.
We are not cutting a lot of trees. So so the first process that we went through was to map out all of the trees on site and sort of maneuver through them and see where we can place the blocks to avoid cutting maximum trees. That is the basis of how our form even came up.
but it's not coming across in the presentation because I know that it's very difficult to work with the trees, and it would have been like you could have made actually a massive case in your design with the shading. You're right about the shading and the passive design, even with the plantation that is there. But in this case, what you show here and the Google map, they don't correlate.
No, actually, like we use like a thin stretch of like the portion which is like towards like the northwest. Like even in the section, it's like really light in the presentation. But if you can see all of that, which is like in between the courtyard, like we haven't cut down on them.
So on the side, the northwest part was the area of least tree density. Hence we started from there, and then anything that's heading into the side has been placed within the gap, and it's also been accommodated to the
And that was also like another reason that we placed the curving courtyard, the balconies, because that's where we accommodated like one of the tree, which is just not to cut it.
Okay. I mean, I'm just saying that in the presentation, that particular bit is not coming across very strongly.
Next time we'll probably overlay it to like convey it better.
Overlay it because that's a very important factor in the design.
Right.
Okay. Okay. Thanks. I think overall it's a very good presentation. Just that for me, while you try to maneuver the whole buildings and everything, it would have been nicer had you actually even taken, like, probably like bridges without actually touching the landscape. And that also kind of speaks about how the water flows, the surface runoff, so that the recharge for the lake would have actually happened, probably elevating it slightly, so that the whole landscape, because this is a very unusual site. It's very nice.
So I didn't get your first point.
I'm just talking about like had it some measures to probably lift the buildings, wherein the landscape that is there with all the trees and all the surface runoff of water, all of those things could have been considered in the design. But I'm just saying, just an afterthought. Overall, you don't have to respond to that. And trying to see how you can actually touch the landscape as little as possible, in particularly sites like this. Okay.
To answer to that, like we actually have like stilted areas and everything, so that that can cater to such things, and like, as you said, touch little of landscape and all. So even like in all the sections, like open areas and even in the master plan, like you can see like most of the open spaces are left, and the recharge, I mean like the ground water, like which is flow, is also catered to that. That was also considered for rainwater harvesting and etc.
And we also like tried to go a little like vertical. Like if you can see that there was a planning strategy as to how we didn't just spread the blocks across the entire site, despite then we had the area. So that's one of our sensitive design to, not touch the landscape that much.
Thank you.
Thank you.
Thank you, jury members. Thank you, Team Aurum. We'll be taking a small 10-minute tea break before we begin with the third presentation. Tea will be served right outside the hall, and request you to please not get your teacups inside. Yeah. Folks online, I request you to stay tuned, and we will please be here with us to support the upcoming teams. Welcome back to the presentations for the Educational Building Division. Our third presentation is from Team Green Collars. They have worked on a project, Ekagra, the Delhi Public School, in Nagaon, Assam. The project partner is Gyandeep Foundation. Team, you will have 20 minutes to present your work to the jury. At 15 minutes, I will ring a signal like this. You will not have a 21st minute, which means at 20 minutes, we'll stop you and ask you to end your presentation. After that, we'll have 10 minutes of Q&A session. Please keep your answers direct and to the point. Okay, team, all the best. The stage is yours.
With the global GHG emissions raising the global temperature and making climate change a real threat, the future of life as we know it on our planet Earth stands questionable. One of the few ways we can attempt to ensure a safe and satisfactory future for the generations to come is by implementing sustainable practices. Our school, Ekagra DPS in Nagaon, aims to accomplish this very goal. Good afternoon. We, Team Green Collars, are a team of 14 students from RV institutions. We'll be taking you through the collaborative decision-making and integrated design approach that our team has taken. We are grateful to our faculty, judges, project partner Gyandeep Foundations, and our industry partner, Zerin Bricks, and architect Neelam Manjunath from CGBMT for helping us throughout this journey. Located just off NS 37, our total site area is 77,000 square meters, of which we are proposing phase 1 of construction with the site area of 43,000 square meters. Situated in warm and humid suburbs of Nagaon, Assam, the school with a built-up area of 8,072 square meters and a ground coverage of 4,000 square meters is proposed to host 1,800 students and 200 teachers and staff, with the possibility of future expansion. The campus works on build-to-operate model and targets to serve students in Nagaon and its neighboring villages. Our design caters to site issues such as high humidity, waterlogging, flooding, and high water table, the abundance of bamboo and other raw materials such as jute, rice husk in the region has provided us with the opportunity to innovate. While designing the school, our team focused on two primary aspects. One, to design a facility that enhances the sharing of knowledge and productive learnings in school. And two, to make the building a net zero energy, water, and low carbon built environment that is inclusive and universally accessible.
Our building has achieved a net positive energy with an EPI of 26.5, which is a 70% reduction from the Griha base case, net zero water, which is a 63% reduction from the NBC base case, and the carbon emissions per functional unit of 70.7 kilograms, which is a 77% reduction from our base case. The school operates on interactive learning, functioning on the motto, you run the school, aided by the integrated BMS system, UI UX displays, and our very own research and design block, collectively known as the Vision Wonder. The building is oriented along the northeast-southwest axis and on the higher contour, which controls flooding and prevents waterlogging, as well as enhances natural drainage. There's an earth mound present on the northeastern side of the site, which cools the incoming air using neem trees. The northwest and southeast areas of the site are shaded using a dense foliage of neem trees, which enhances cross ventilation by allowing breeze at lower levels. Shrubs and ornamental trees are placed to enhance the sensory experience. Passive design strategies have been implemented to take advantage of the natural wind and air and light available on the site and reduce energy consumption while maximizing comfort. This has been done by orienting the building along the predominant wind direction, which is 19 degrees to the east. The school contains staggered classrooms and a courtyard enclosed on 3 sides, which enhances self-shading and wind funneling, aiding in cross-ventilation. 84% of the building is passively ventilated, which includes classrooms, staff rooms, admin, and the activity rooms, while 16% of the building requires HVAC systems during the summer months. This includes the MPH, seminar halls, as well as the R&D block. This has been derived as a result of the privacy, usage, equipment, and ACH norms which were inferred from the simulations. Thus, our site has been optimized for shading, ventilation, as well as earthquake resilience. The northeastern The northeastern facade has fitted with bamboo louvers coated in titanium dioxide epoxy resin, which acts as light shelves. The roofing consists of a north light truss, which optimizes light and wind infiltration. The window to wall ratios have been optimized to maximize daylight infiltration while keeping the heat gain to the minimum. The southwestern facade is coated with mosaic tiles to reflect heat. The other two walls have minimum solar exposure due to their shorter dimensions and self-shading. The rest of the walls are shaded using bamboo jalis, while envelope optimization has been done to reduce U values. The southwestern facade, which has a high radiation, is shaded using a combination of inclined vertical and horizontal shading devices. The EPI has been reduced to 26.5 as compared to a Griha base case of 90, as well as a project partner base case of 73, through a combination of passive design strategies, better equipment, as well as wind, water, and daylight optimization. Equipment optimization includes the use of energy efficient LED lights, HVAC right sizing, as well as innovative use of equipment like the coupling of a heat pump as a refrigerator. LPD has been reduced to 4.7 and due to the use of efficient lighting fixtures. HVAC set points have been derived, further reducing our energy consumption. VRV systems are preferred over water-cooled systems owing to the high humidity of our site, as well as the high maintenance costs and its utility during disasters. Solar energy has been harnessed over 1,550 square meters out of the total roofing area of 4,700 square meters. The site receives an annual rainfall of about 1,500 mm, which is stored and collected. During collection, the rainwater flows from the roofs to the underground tank and thus possesses energy that can be harvested. Our proposed innovation, the Hyderabad Impulse Turbine, generates about 3,500 kilowatts per year and has a net diameter of 0.8 meters, thus very space efficient. We have 3 such units situated near the rainwater harvesting tanks. The solar panels and the impulse turbines together generate 2.2 lakh kilowatt hours per year, which exceeds the annual consumption by 11,000 kilowatt hours, making us net positive. We have achieved net zero water on our site through a combination of reduction of consumption, wastewater recycling, and rainwater harvesting. We have reduced the consumption from 45 LCPD to 16.27 LCPD through usage of efficient fixtures like smart faucets, flushless urinals, as well as washing and cleaning equipment optimization. Landscape water consumption has been reduced to 3 kiloliters, and the total water consumption during construction has also been reduced. We have an annual rainwater collection of 9,700 kiloliters, which is filtered and then run through the turbine before it reaches the rainwater tanks, which are considered over-surface storage solutions owing to the high humidity of the site, as well as the issues of stagnation. The water chart shows how water is harvested and treated on site. The black and gray water can be treated together in the eco-STP, which uses bacteria instead of chemicals before it is recirculated and used for flushing, as well as irrigation of bamboo plantations located along the periphery of the site. The sludge from the STP, along with all the wet waste generated on campus, can be used for generating biogas, the residue of which is composted.
To achieve the 77% reduction in embodied carbon with respect to the base case, a 3-stage approach was used. Stage 1, which is the whole building design. Some of the strategies include designing to minimize waste and using on-site treated bamboo. Stage 2, which is the one-for-one material substitution. For instance, AAC blocks used in the base case for the external walls were replaced with plastic embedded interlocking Xerin bricks, which are composed of 70% disposed plastic, along with 50 mm diameter bamboo poles, which completely eliminate the need for wet fixing, hence allowing the materials to be completely dismantled and reused, and thus enhancing the circular economy. The walls are internally clad with bamboo mat boards. A filler slab made of locally available terracotta clay pots and the vernacular red oxide flooring, which is durable and cost efficient, has been used. Bamboo is extensively used throughout the project. The Northlight Truss members are treated with boric borax and are fabricated on site. Additionally, 2 layers of amateur fire-resistant paint has been added. A sandwich bamboo corrugated roof sheeting along with glass wool insulation has also been added. The door frames, shutters, and windows are made of bamboo ply, and the louvers are made using beaten bamboo. ACC Ecomax green concrete, which is structurally similar to regular concrete, has been used. Stage 3, sourcing. All the building materials have been sourced from a distance of 160 kilometers, which is considered local according to the US GBC LEED V4. The motto, "You run the school," has been taken as a model for developing a concept that focuses on a new model of education. Organic farming has been introduced as part of the weekly schedule. The Bacharon lightweight multifunctional modular panels can not only be used as internal partitions, but also allows students to shift it either within the building or take it outside to construct a makeshift shelter that provides shade. Our team has also proposed a system, the Vision Wonder, which the project partner can choose to implement in the future. Each block can be equipped with a UI/UX display board, along with sensors which inform the students about the current temperature and humidity levels of the space. It is well integrated with the building management system. Hence, when a student inputs how one feels in the space, the energy board displays a solution for maintaining a comfortable indoor environment, which can then be performed by the student manually. Some of these functions could include adjusting louvers or opening and closing windows. The smart processing algorithm controls certain functions like storage overflows, fan speeds, and lighting automatically. The play equipment, when used, generates a small amount of energy which is stored in batteries, and this is in turn used in the research and design lab. The batteries which store the energy are used to power the lab equipment and also for conducting simple experiments that teach the students how their small actions can contribute to a greener environment. In addition to the above-mentioned results, our team has also achieved 100% comfortable hours, 75% daylit hours, 12% capital cost reduction, and also worked on an additional function of an immediate flood-resilient shelter for 4 days. 100% comfortable hours are achieved through the following strategies. Cooling and dehumidification are considered potential solutions in warm and humid regions. Hence, through natural ventilation, increased wind speeds, and passive design strategies, the mechanical cooling load has been drastically reduced. Referring to IMAC, considering a 90% acceptable range and an elevated airspeed of 0.7 meter per second. The upper threshold comfort was increased by 2.5, which allowed for a mixed mode operation, with about 84% of our spaces being naturally ventilated throughout the year, and 16% spaces are mechanically ventilated majorly in the summer months of April to July. For the non-air-conditioned spaces, 352 of the 2,200 hours are made comfortable using fan-forced ventilation. Indoor air quality has been improved by introducing plants in the courtyards, which provide oxygen and purify the incoming air. In addition, using low VOC materials and the use of bamboo mat boards completely eliminate the need for internal plaster. A sufficient ACH has been ensured for each space. An average sound level of 60.7 dB has been observed on site. Hence, spaces have been zoned such that the classrooms and the MPH are located away from the highway. The indoor movable acoustic panels have retractable upper and bottom seals, and the sandwich bamboo mats, jute fibers, and rice husk have good sound absorption. Thermal shock has been reduced by incorporating semi-covered spaces and staggering of classrooms along with landscaping, which provides self-shading and gathering spaces for students. A UDI of 75 has been achieved by taking maximum advantage of the northern facade and the north light truss to satisfy our requirements. It also exceeds the super ECBC condition by achieving 90% daylit hours for 67% of the spaces.
The site lies in earthquake zone 5. This area is subjected to frequent flooding for 4 months a year. High frequency, high impact hazards like floods, waterlogging, thunderstorms were taken into account, and various design solutions were worked upon while keeping the critical functions of the building active. The building has been compartmentalized into 5 zones for structural and fire resilience. The RCC frame structure is designed with expansion joints to resist hydrological forces. The building has been placed at a higher elevation and built over a porous plinth of 600 mm, aligned in the water shedding direction to avoid waterlogging and flooding. The earthing system has been designed for resilience against thunderstorms. Materials with high fire rating have been used for the structure, and the MPH is designed with bamboo portal frame, which is used as a community resilience shelter for earthquakes. The building acts as an immediate flood resilience shelter for 4 days for 500 people, within which they will be evacuated to the nearby Mokhati Resilience Center, which is 1.2 kilometers away from our site. Energy requirements of 5,900 kilowatt hour stored in 20-watt batteries, and water requirements of 100 kiloliters has been provided for necessary activities. To cater for the food requirements on site, biogas is used for cooking, and food is stored in a space of 1,000 cubic meters, divided into a refrigerated space, a kitchen loft, and under the staircase. Organic farming with crop rotation and mixed farming techniques is done. The multi-hazard risk assessment was done, and recovery plans have been devised for various disasters. For climate change, we have derived a trend line from the existing data of the past 10 years and for the next 15 to 20 years of the building. As seen in the graph, temperature and rainfall are increasing, whereas humidity is decreasing. Therefore, bioswales have been put in appropriate locations to avoid flooding, whereas drainage systems to prevent debris blockages and backflow of water. For indoor comfort, fans have been provided. We also have an additional roof area of 3,000 square meters with a solar potential of 4 lakh kilowatt hour in case energy requirements increase. The safety prism is a bench with a top that can be rotated 240 degrees to convert to the most stable form of geometry, which is a triangle. During an earthquake, to transform into a protective shield against falling objects. It is designed using locally sourced bamboo ply, as well as welded steel joinery. The slide displays the final design and site layout. There are total of 4 fire exits, ensuring quick and safe, efficient evacuation in the case of emergency. The fire escape paths are all indicated in red. The HVAC spaces are indicated in blue and services in pink, while the classrooms have been placed to take advantage of the prevailing winds. The site is accessed from the south. Features like sensory gardens, sports facilities, and bamboo plantation provide outdoor learning environment while engaging the 5 senses.
In constructing the above design, we have achieved a 12% reduction in capital costs. Our base case cost has reduced from 307 INR million, and our design cost is 267 INR million. A major chunk of the cost has been reduced by optimizing building height and loads to make the building a G+1 structure, allowing us to use isolated footing instead of pile foundations. Using local materials like Xeron bricks and bamboo, hence reducing wall and fenestration costs. Optimizing water consumption and reducing water storage costs, and reducing furniture costs by innovating our very own earthquake-resistant furniture. Operational costs have been reduced by using local and low-maintenance materials and energy-efficient equipment like the Eco-STP and the VRF system. If we compare the base and design cases, our case has an additional cost of efficient materials and equipment used to make the building a net positive energy and net zero water building. This appears as an additional cost of 40.4 INR million. However, considering the amount the base case building will have to pay for energy and water each year, this amount is compensated within 5 years. We have also identified some financing options provided by the Assam Green Budget, which could be applied to our building. The advantage of our building to students who are our main end users is that the school offers more than just a typical learning experience, enhanced by the R&D block, hands-on learning, and a flexible and green environment to learn with the motto, "You run the school." This is supported by 100% comfortable hours, 75% daylighting, and a multi-resilient structure. Along with this, we are proposing 3 main marketable and scalable products to the project partner. The Vision Wonder, designed as a scalable model, our in-house BMS, UI, UX, and R&D block can serve as a cornerstone within the DPS franchise and can be integrated in other institutions as well, helping to inspire creativity and enthusiasm in students. The Hydrowatt Impulse Turbine System, a groundbreaking twist on a water vortex, it harnesses the power of rainwater and generates energy in a compact design with low maintenance. Its low flow rate makes it viable across diverse environments. The Safety Prism, a reliable design that provides a functional workspace and doubles as protection from earthquakes for students of different ages. It is easily adaptable and it can be constructed using locally sourced materials. From creating a prototype of this, we realized that these materials can also be replaced based on availability. We would like to conclude by comparing 2 worlds. One world is the world we live in now, a world where the building sector is contributing to the threat of climate change and where schools continue their monotonous ways of textbook learning. Another world is a world with schools like ours in it, a world with facilities that enhance the sharing of knowledge. Thank you.
Thank you, team. You delivered really well. Let's hear the jury comments and then take questions from them.
Hi, thank you very much for your presentation. I think it's very nice. I do have a comment that I think the slides had just too much information because it was difficult to really get to the point that you were really discussing. So I think visually they were very troubling. So now coming to the real, kind of design questions, I think what I really liked is that your presentation tried to address some of the questions that I had raised. So well done for that. I think that I could catch those, points kind of coming through. I did not get one, which was this, that since your building is, again, like some of the other teams, majorly naturally ventilated, what have you done in terms of, the window design? How much percentage of, window openings you have kept? Have you taken up any calculations to test, right? I'm going to pose another question and then let you answer all that. That's one. Second question is that you talked about these plastic embedded bricks, right, as one of the innovation things. So I personally feel that, I don't like the idea at all. I don't like the idea of, embedding plastic in bricks because, you tend to forget what happens at the end of the life, right? Normally, a brick would kind of degrade into smaller pieces of brick, but they do not release any toxics in the environment or the, the water and the ecosystem. But brick embedded with plastic will eventually break into plastic pieces that will actually release all these toxics at some point, 50, 60, 70 years when after your building actually, is used. So I raised this question, so I'm hoping you've thought about it. And the third question is that BMS, I think because you're trying to sell that as an innovation idea, how does your BMS system work for the non-AC spaces? Could you explain it? Yeah. So 3.
Okay. So with regards to the wind, right, the naturally ventilated and the AC spaces. So the AC spaces you can neglect because they have forced ventilation. With regards to the window wall ratios and the naturally ventilated parts, we have designed different iterations. And we have tried to go with CFD analysis as displayed there, right? With taking the worst case scenario of the minimum wind speeds available on the site for most of the time, which is 1 meter per second, which is very low. And from that 1 meter per second, the amount of wind entering the classrooms was about 0.6 meter per second to 0.7 meter per second, which according to the IMAC tool, in that given condition of summer is good enough, right? But in addition to that, if you want greater comfort, we have the integrated BMS system, which takes in user input saying, I'm feeling hot, right? A student inputs that he is feeling hot or sticky, And that will give you a particular solution. Either you can tilt your louvers which are present there, or you can switch on the fans. So we have an option of fan forced ventilation in case there is no wind blowing out, as well as we have trees around the campus which keep the ambience naturally a little bit cooler as compared to the ambient temperature outside the site. So that's the answer for that.
Okay, in portions, I think I like your answer. In portions, can you take up a section? You have an image of the classroom somewhere, right? Or anywhere, any image, which can be a good reference point to see the windows, Like one of the questions is how much percentage of your window is operable, right?
Okay, so with regards to that, 100% of the window is openable. You can open it out, right? Except
and how much percentage of the floor area is that, right? That was the question initially when I sent it to you. Is it meeting codes, or have you done any calculations?
We did look into your question, and I think so. Our classroom area is 60 meters, 60 square meters, and we did it has to be about the window area has to be 60% of the floor area, and it is meeting that requirement.
60%, where I think that's too much. Anyways, because I think probably most of the codes are around 10 to 15% for ventilation purposes, not daylight. That's a different matter. So you should be meeting that much. And then, I would have liked to see, your thinking. So you have done bits of it, but it would have been good to see whether the positioning of the windows had been thought, for a very still day, right? You answered that in a way by saying that you have some kind of fan system. Is it ceiling fans?
We have 3 ceiling fans, which are provided, as well as 2 wall fans.
Okay, the question for you to think there would be that why not exhaust fans, right? Because you're trying to pull the outdoor, because if there are like a lot of people in the room, your humidity levels are going to rise inside. So you want to pull fresh air from outside, mostly. And fans will increase the wind speed, increasing comfort thermally, right, temperature-wise, but they will not decrease your kind of the humidity load. So you'll have to pull. So you should have thought of exhaust fans being incorporated, and that will actually get you closer to that goal of yours. Okay, and yeah, the next question was the bricks.
Yeah, so to address to that, the project partners, Zerin Bricks, it's a company that started in Assam and Guwahati. So they basically take disposed plastic from the landfills, around 500 to 600 kgs, to manufacture their bricks. So our thought process behind picking these bricks was that we are clearing that much amount of plastic from the landfill by making these blocks which act as carbon sequestering materials. So they trap the plastic within the brick itself, and during the lifespan they do not emit any emissions. And considering the fact that our site is located in a zone 5 earthquake region, so the other alternative we couldn't pick was to use AAC blocks, since these blocks were more earthquake resilient as compared to those. We thought we'd go ahead with that. And to also reduce the carbon further, we have used like the 50 mm diameter bamboo poles that sort of reinforce the entire walling system together. So that way the amount of carbon emissions has been drastically reduced.
Yeah, carbon is fine. Okay, just sorry, I'm going to take one important question. You mentioned somewhere that 100% of your classrooms for occupied period are comfortable. Could you go to those charts once and just kind of convince us once again on that? What are the peak temperatures that you get in the city there in Assam?
We get the peak temperature as 31 degrees in the summer months, from April to July, June being the highest temperature month. So we also have summer holidays in June, so that cuts down that load. As well as we have provided, as seen in the simulation, we could achieve good natural ventilation in the classrooms, because the classrooms were the major points in the school which needed natural ventilation, and R&D block and all the other spaces were actually arranged towards the south, so that because they were already HVAC controlled spaces. A portion of it, the red.
The top chart, please. Just
Yeah.
that. How could you explain it? What is
So
it
that
showing?
shows, that was done on Design Builder, and that shows from natural ventilation we were able to achieve the number of hours of the comfortable hours, whereas the red portion actually shows which we couldn't achieve, which was 352 hours without natural ventilation. So that's why we're providing.
So your
fan
yellow
first.
band, somewhere in the middle of the year, June, July, is actually going up till 30.
Yes.
You're saying you are accepting 30 C operative temperatures at that point, 30 or more than 30 probably. That.
No, so those were the the comfortable hours where the building was not achieving comfortable hours using natural ventilation. So we are providing fans to achieve that part, that is 352.
Acha, what is that limit? Just give me one number. What was your,
upper
set
threshold?
Point, upper threshold for
So we
comfort?
the temperatures range from 22 to 29, with the upper threshold being 31. So we can achieve natural ventilation within that limit. So that's the thing.
Okay.
IMAC model is for naturally ventilated spaces or it's mixed mode?
We took for naturally ventilated spaces. We could have taken for mixed mode, but with mixed mode, we get a larger variations in the ranges. Whereas with natural ventilation, we got a smaller one, but we could still achieve that range of natural ventilation. So we went ahead with the natural ventilated part because our area's 84% is naturally ventilated.
So by that you mean the fans will not be used at that time?
It can be if you want to, but as seen in the simulation, we don't need the fans because of the wind speeds that we are able to achieve in the classrooms.
I'm going to pass it on, but just a point of caution regarding wind speeds. When you work out, ventilation system of a classroom, generally there are two types. One is, wind-driven ventilation, which you're talking about, and the other is buoyancy-driven. That is, buoyancy happens when it's very still. And the wind speed data that you get in weather files is usually, and kind of a, within a 10-minute interval or 30-minute interval, the maximum it goes to. All the rest of the time, because wind buffets, right? It's not a continuous. It's not like a, kind of a duct that it's continually flowing. So for a lot of the portions, it will be very still. So you should start thinking about, what happens in that still, conditions, including that exhaust fan, and including, your ceiling fans.
Yeah, so to address that, if you look at the rightmost image, so you can see that on the northeastern side, where we have the incoming air, we have one large window. Okay, that is for the incoming air, right? Whereas on the other side, that was the slide. Yeah, so yes. So on the other side, you can see that we have two windows, one at the top and one at the bottom, which are reduced in dimension to remove air. So the one at the top will be helping you with removing the hot air due to buoyancy or convective effects. And we also have included a north light truss, which can act for incoming air if there is wind, and also help in evacuating warmer air in case of buoyancy. Yes, that's two classrooms. We have taken an entire section of the G+1 just to demonstrate the stack effect as well as the cross ventilation.
And there was this comment about the BMS for the non-AC. How does the BMS work for the non-AC?
For the non-AC spaces, the BMS, our UI UX boards will basically are integrated with the BMS system. The BMS system has temperature and humidity sensors, right? So if a space is too hot, the BMS system will sense that, and it will be shown on the UI UX board. And as the UI UX board will also take in user inputs and give a solution for how to make the space more comfortable.
One more thing I'd like to add is that we're focusing mostly on user inputs. So regardless of how much of a comfort you try to simulate, the user input or what the person there is feeling is the most important part. That's why we have integrated the BMS system to majorly take user inputs to change the ambient conditions, like switch on fans or recommend the changing of angles of the louvers, etc.
Okay, I just want to add 2 points. You don't need to answer anything. It's more like a comment on the same subject. One thing is, when you talk about thermal comfort, operative temperature is like you have to take into account the alpha value or the air velocity. And the second very important part of it is the mean radiant temperature, which is the, or let's say it's more like, you can say a part of it is also air temperature, which is there. But right now what you're focusing heavily on is only air velocity. So probably that's not a right way to look at it. You also need to consider the mean radiant temperature in it. That's one thing. So keep that in mind once you're doing the analysis later on. Second point is you spoke about controlling these spaces through BMS system, and the control is with the occupants, which is the students. Now let's assume that there will be 40 to 50 students sitting in one classroom. It is very difficult because everybody will want a different type of set point, right? We all over here will not be comfortable with the same set point. So it's a very tricky thing, by the way, to give the set points in the hands of the students. So that's also one thing that you need to consider. So it's just a comment. Maybe in the interest of time, we can quickly move forward. I have one question with respect to acoustics. Maybe you can try and address that. If you can go to that slide. I think it's quite commendable because I think it's only your team which has addressed the subject of acoustics, and probably it's even not a part of the competition, but then it's more like taking a step ahead, and you have addressed and included this as a part of the well-being, which is a very, it's quite a commendable thing. But one point over here is, I have a lot of questions on this slide, but one thing is when you talk about reverberation time, 1 second of reverberation time probably is like a cutoff. Okay, it's not a very great number to look at. RT values ideally should be less than 1 second, especially in case of classrooms. Ideally it should be at least 0.6 to 0.8 is what is acceptable. That's one point. And I guess you are also kind of mixing up this concept of absorption and isolation. Again, these are two very different concepts in acoustics. If I look at the design of your space, if you just zoom into that particular image that you're showing, that in itself has gaps in between. So this is making your space like, I don't know, how are you isolating the classroom, because there's a free pathway for the noise to transfer, right? Isolation is all about you are sealing it appropriately so that the noise leakages are minimized. But here, I think the design itself is not allowing it. And the value, I think this is a new thing, transmission coefficient. Probably this is what you've added in the report, it's not there. So again, the questions would be on that, like, is it a tested value or from where are you getting it?
So with regards to the transmission, I'll address that first. That is a calculated value based on the testing of the materials. We have taken standardized materials like a bamboo mat or the jute panels or rice husk boards, and through those calculated values of elastic coefficients, etc., we have arrived at that transmission coefficient that displays how much energy goes through the panel depending upon normal incidence of sound. And with regards to the classroom isolation, those panels in between are actually movable. They can be removed or added, so the sound is actually isolated. So there is an animation which shows that they can be removed. So to integrate 3 classrooms, make it like a combined class or some exhibition or something. And with regards to the reverberation time, that reverberation time is considered taking only one wall with acoustic panels. The other walls are considered as perfectly reflecting and no sound is leaving outside, no sound leakage, no windows.
And how have you come up with this value?
Through calculations again.
So you did manual calculations for this?
Yes.
Okay.
So if we do consider that all walls are acoustically insulated, the value comes out to about 0.4.
Okay.
About 0.4.
Okay. I'll just close my comments with one thing. I feel that you guys have given attention to each and every subject very nicely. In my opinion, I thoroughly enjoyed reading your report, going through the details. Each and every section, including innovation or well-being or energy performances, I think is quite well done. And your team seems like a very well-coordinated team, if I have to put it in one way. So that's also, like, it's quite commendable.
I would like to add on to that. Definitely enjoyed actually seeing your presentation. It's your effort and the presentation overall is very commendable. And I had the similar questions. I think you already answered, so I don't have actually a question except the comment. Especially my question was what Harsh was also talking about. One thing I really liked actually, first of all, before anything else, is that you started with the landscape, not the building. And you spoke about the plantation. I think that's really nice to like look at not just the building, but also the surrounding environment and how it can impact the spaces. That's a very good start. And I was really intrigued about the prototype that you did for the furniture. So you guys made it for this competition?
It's there near the post.
Oh, it's near. So you made it for the this.
It was too large, so we weren't allowed to bring it here. But it's near the poster in the exhibition hall.
That's really nice. So yeah, overall, very good job, guys.
Thank you.
Thank you, jury members. Thank you, team green collars. Let's take a 2 minutes break and then start with the next presentation. We'll begin with the fourth presentation. Our presentation is from Team Lens. They have worked on Samaya Gurukul, located in Dhubri, Assam. Their project partner is Karunar Kheti Trust. Team, you will have 20 minutes to present your work to the jury. At 15 minutes, I will ring a signal. You won't have a 21st minute, which means at 20 minutes, you have to stop and end your presentation. After that, we'll have a 10-minute Q&A session. Please keep your answers direct and to the point. All the best, team. The stage is yours.
Greetings of the day. I am Vishal Dayani, team lead of Team Lens, and today we, Akshita Rathi, Shreya Bide, and Omkar Joshi are here to present our project Samaya Gurukul, Primary Girls School and Vocational Training for Women. Our ongoing project is located in Dhubri, which lies in warm and humid climate. Dhubri faces various challenges, one of the primary one being low education index and inadequate infrastructure of schools. Stats suggests that 1 in 3 children lack schooling. There is 11% gender gap in literacy. So a genuine focus needs to be there on education, especially for the girl child. According to the SDG report by Niti Aayog, Dhubri in Assam is ranked as the worst performer in education, gender equality, and economic. Unfortunately, only 37% of children are currently enrolled in school because of inadequate infrastructure. Recent news articles suggest that there are 1980 schools in Dhubri, out of which 1087 are primary institutes, and they lack sanitation, well-being, and comfortable environment for the girl child. So our current site lies in no flood risk zone, which is 2.1 kilometer from the shore of Brahmaputra River, elevated at 26 meter above the sea level. It has a contour difference of 3 meter, where the highest point is at 29 meters and the lowest one being at 26 meter. Now let us focus on the concerns of the parents of Dhubri, why they do not prefer sending their girl child to the school. The first one is the co-ed schools. Second, safety and lack of comfortable environment. Third, sanitation and well-being. Fourth, responsibility over younger siblings. According to the report of Ministry of Housing and Urban Affairs, out of 10, 8 elder girl child had to stay back at home to look after their younger siblings because both the parents are working.
With our design being girl-centric, we divided the site into 3 zones. The first, public zone, caters to the local community of Dhubri. The second, semi-public, caters to the parents of the children coming to our school. And the third, private zone, caters to the female students, their siblings, faculties, and mother. To reduce the sun glare, the longer side of our building is oriented towards the north-south direction, and the staggered form of the building allows the predominant wind which comes from the southwest direction to funnel inside the campus. In order to induce the 5 senses of a human being psychologically inside the children, we have spread out hierarchy of courtyards throughout our sites which have the native trees of Assam. At the last, a semi-open play area is scooped out so that these kids can learn beyond the 4 walls and have an outdoor learning space. The journey of the mother, her 2 kids start at 8 AM when they book the bus through Eero app, which is affiliated with Education on Wheels, our innovation at community level. This bus leads them to the premises not only during the calamity days but during the regular days also. As per the design concerns, Samaya Gurukul caters to 3 functions, namely the primary school for the elder child, daycare for the younger child, and vocational training for the mother. our site has 3 different entrance points. The first one leads to the auditorium space, which is open to the local community of Dhubri, but yet guarded through the landscape area so that it is physically separated from the whole premises. The second entry point leads to the vocational training area, which is like a second home for these mothers, and where they learn to make bamboo weaving, embroidery, and paper making. The paper made by these mothers are again used within the premises for the kids. While these mothers are in the vocational training, their younger child through the admin space enters into the daycare area, where they engage with different children and spend their time. While the mother is in the vocational training and the younger sibling in the daycare, the child enters through arched opening into the school premises, which is guarded by our second innovation, which is vertical axis wind turbines. These turbines are not only just an innovation for energy generation, but it also helps them to understand how a kinetic energy gets converted into electrical one. Coming to the classroom detail, the classroom is divided into 2 parts. The semi-open area acts like a buffer zone and is a gardening area where the children themselves learn to garden in that space. The second one is a sitting area where they get their theoretical knowledge. And as explained earlier, during the orientation to the north-south direction, we have a scope of north light truss, which furthermore gives us a scope for having solar PV panels on the southern side of the roof. The bamboo jali walls placed towards the windward side allows to funnel in cool air, while the leeward openings on the higher levels in the leeward side allows the hot winds to escape out. So basically thermal comfort is achieved inside the classroom during the occupancy hours of the children. Through series and hierarchy of courtyards, the child leads to the central play area, which has another innovation, bloom. There is a green ramp which takes to the first floor, which has an interactive wall with mathematical tables, stick games, and scoop outs for the children to sit and play while learning. Another way to reach the first floor is through this playful staircase, which has a cozy space beneath it where the children can again play and engage and interact with others. In all, there are 4 classrooms on the first floor, and then again from the ramp, the children can roll over and paddle and reach to the dining area at 1 p.m. That's the time where the mother and her children bond together over the dining space. The dining space is in collaboration with the government scheme, which is midday meals. It acts as a magnet so that the children can come, and as per food security, we have total 3 days food security in our dining area.
Now let us talk about the simulations which we have run from Design Builder. The very first analysis we did was CFD analysis, in which, as mentioned earlier, As mentioned earlier, we have added a buffer zone in the design case where the WWR has been reduced from 60% to 30%, and a comfortable range is observed here from 22 degrees Celsius to 25 degrees Celsius, the temperature range. The second analysis was to study the illuminance level. So the illuminance level must be between 100 lux to 2000 lux as per GRIA 2019 volume 1. So in base case, 70% of spaces were getting into this range, whereas in the design case, 85% of the spaces were getting into the desired range. When we overlap the occupied hours with the comfortable range, we can see that all the occupied hours are in the comfortable range. When the same piece of information is overlapped with the simulated temperatures, the operative temperature getting its maximum up till 27 degrees in the peak summers. When we talk about the comfortable annual hours, in the base case it was just 67%, which went up to 85.3% in the design case. So a series of passive cooling and dehumidification strategies were employed, resulting in an increase of the comfort zone from 17% to 56%.
To further elevate our design, we introduced a few innovations to it. The first being the algae facade, which is a customized panel with 2 glass surfaces and algae water is introduced between. The next is foldable furniture, which is in our multi-purpose space. It is made out of panels which can be stacked on one top of other to create an open area. The third innovation is vertical axis wind turbines. This is a 3-meter height wall, which consists, the upper half consists of wind turbines made out of waste PVC pipes. This helps in generation of energy. The lower half consists of rotating bamboo tubes, which when stacked together create a playful environment for the children. The wires can be passed through these bamboo tubes. The motor is connected at the bottom of it. This helps in generation of 17% of our total energy. The wind required for rotation is about 10 kilometers per hour. Speed is required, which is only available for 5 months in Dhubri. So to know the cost of this innovation, one turbine cost up to 90 rupees and the total assembly cost up to 2.3 lakhs. But the payback period for the same is 1.12 years, which is only 13.5 months. Our next innovation is called Bloom. This is for collecting rainwater, which is placed in our playground area. The inspiration was taken from foxtail orchids, which is a local flower of Assam. Another element for this innovation is generation of energy. The rotating turbine, which is placed at the bottom of the pod, helps in generation of energy. Due to the inefficiency of the system, the energy generated is however low, but the intent here is not generation of maximum energy, but educating and creating awareness about energy generation and sustainable methods of creating energy. Our last innovation is on a community level. This is resilience education on wheels. It is a bus which helps bring the students and their mothers to our school. During calamities, this bus can bring the victims to our resilience shelter. It is affiliated with the Eero app, which helps keep pickup and drop locations. Also, the schedule and workshops going in our school. Okay. So to understand the energy diagram, we have the energy generated on site, which is utilized for various activities, and the excess is sent back to the grid. The total energy consumption is 1,03,000 kilowatt hours annually. This is distributed between various functions in the school. For EPI calculations, we did it on 3 levels: the base, intermediate, and design case. For base case, we considered ECBC 2017 criteria, and we reduced it using different strategies which were explained earlier. The final EPI calculated was 30.4 kilowatt hours per meter square. The target EPI was 38 kilowatt hours per meter square. The maximum energy generated on site is through solar panels, which are placed on 1,000 meter square of our roof area. The energy generated is 82% of the total energy. So total energy generated is 1,50,000 kilowatt hours annually. So we can see that the total energy generated is more than the total energy consumed, which shows that our building is net positive. Now coming to water cycle, the water collected from rooftops, our water collecting pods and permeable pavers is filtered and collected in water tanks. Groundwater can be added during summer months. It is used for various purposes, and the grey water collected is recycled and used for toilets. The black water can be further recycled and used for irrigation. We have LPD per person in school is 45 liters, which is for various activities, and grey water treatment and black water treatment map is given here. So we did the statistics for consumption, and the water sources were calculated. And yes. So coming to the carbon emission, we have used unconventional materials such as bamcrete walls instead of brick walls, or replacing 50% of Portland cement with GGBS, and also clay plaster instead of gypsum plaster. This helped us reduce the carbon emissions. All the materials were locally sourced, and we tried to reuse many materials. So carbon emission was further calculated for roofs, wall, fenestrations and structures.
So in climate smart interventions, the very first thing what we did is use of renewable energy source. We are using vertical axis wind turbines and solar panels in our whole design. And in rainwater harvesting, we are collecting water from rooftop pavements, rooftop pathways, perforated pavers, and from bloom to later filter and collect it in underground water tank. In reusing paper, we are using all the paper used in our premises to recycle it in our workshops and then later use in vocational training center. In energy availability, the exhibition center of our premises is the only area which will be used in resilience shelter in the time of calamities. So we have provided a power backup of 25 kilowatt. And in adaptive thermal comfort, as explained earlier, due to our apt natural ventilation and daylight, we are catering to this very successfully. So as per IMD predictions, our site area is in no flood risk for at least next 50 years, but we are still planning to add a retaining wall in the future to safeguard our design. So in earthquake resilience, Dhubri comes in seismic zone 3 of IS provisions. So we have done some earthquake resilience part through ground and through footing also. In ground, we are doing improvement methods of deep mixing and preloading. By preloading, we are doing settlement of the soil even before starting of the construction, and in deep mixing, we are mixing our soil with cementitious material. And we are also decoupling our superstructure from our substructure by adding a shock absorber in between them, which will act as a safeguard to save our superstructure when earthquake will hit our footing.
A 6-meter wide road runs along the periphery of our building for fire tender movement. And as per the materials, the bamcrete wall provides a resistance up to 4 hours, while the mud plaster up to 2 hours, and a use of fire retardant doors are throughout the building. And as discussed earlier, our proposal caters to the job employment for the women of Dhubri and girl education, but our proposal is also in compliance with the government's menstrual hygiene scheme, which is known as the free days, and the sanitary pads will be made inside the vocational training center only, and the children will also get educated about the menstrual hygiene. The value of traditional art and crafts will be made, all the products made in the vocational training center will be sold out in the pop-up shops, and the women of Dhubri will be able to understand their value of traditional craft, as it will turn into a monetary benefit for them.
In engineering and operations part, we have done analysis of our structure in ETABS Ultimate software, and our whole structure is errorless for shear force, bending moment, torsion, and deflection too. Our whole structure is IS 456 and IS 800 code compliant, and we have used 2 types of concrete, that is M20 and M25, and we have replaced 50% of cement with GGBS, and we have used FE 415 and FE 250 of reinforcement, and in advancement in blunt ductile detailing by reducing the gap between lateral tiles. This will act as a resistance to lateral forces like earthquake and wind forces too. So here we can see the deflection analysis for one grid, and we have provided bamboo bracing in bamcrete walls to reduce the lateral forces of wind. Now we shall continue with project timeline.
So yeah, the current total time period calculated for the construction of this project after listing down the item of works was 4 years. When we talk about the affordability part, the base case was getting up to 9 CR, the total project cost, with the cost per square meter of 32,000 per square meter. Whereas in the design case, the total project cost was 10.27 CR, with the cost per square meter equivalent to 36,000 INR. Now, when we talk about the market potential, it was delayered into different categories. The very first being the use of local materials. Second, the engagement of local people, that is working in the lines of our project partner, that is for the people, by the people. By this, we have reduced our labor cost up to 50%. Third, the employment of women of Dhubri. And the last and the most important was demand for girls' school. When we talk about the scalability, we have identified the locations in Northeast region which has similar conditions like Dhubri. The idea here is not to replicate Samaya Gurukul, but to replicate the ideology of Samaya Gurukul. The ERO app would be like a larger web which would be connecting all the dots of education throughout the Northeast region and further to India. What exactly did we achieve by making the Samaya Gurukul? Let us understand. The very first thing, we created a space for appreciation. Second, secular interaction spaces were introduced. Third, a women inclusive program. Fourth, recycling of paper. And last, safeguarding local arts and crafts. By this, we end our presentation. Thank you so much for listening us so patiently.
Thank you, team. You gave a very insightful presentation. Let's take the jury comments and the questions too.
Thank you very much. Firstly, I think I like your presentation style. It's very simple, easy to the eye, easy to my mind. However, it does hide a lot of complexity behind it, and I think we need to push forth a little bit into that to really judge some of your thinking. So, I'll just start randomly because I don't have a clear, a few questions in mind as of now. The first is you made a comment that your site is located close to the Brahmaputra, is it? 1 kilometer away, something like that?
2.1 kilometers away from Brahmaputra River.
Right. But then later on in the presentation, you said your site is not vulnerable to flood risk for 50 years. What does that mean?
Okay, so sir, the recent studies from IMDb, the data which we have studied from IMDb and some of the other sources suggest that the current flooding, the overlapping from the above sea level is just 3 to 4 meters, whereas our site is currently elevated at 26 meters and it is away from 2.1 kilometers from the seashore. So the flood reaching our site is not up till 50 years. So till 50 years, it is safeguarding. Our site is already safeguarded because of the strategic location.
Are you talking about a 1 in 50 year event, or are you talking about the fact that 50 years due to climate change, the levels will change?
Everything, sir. The climate changes, and even we have studied the past incidents, the past floods which hit Dhubri. So those suggest that.
When did it hit Dhubri?
The recent flood which was in 15 to 17 years back.
Correct.
Yeah.
And so a 50-year interval doesn't mean that it's going to strike after 50 years. It would mean it can strike any time, but on an average, over the history of 500 years, 600 years, it strikes approximately 50 years. So am I right that your site is actually vulnerable to flooding?
So sir, as
because I don't, like my interpretation of 1 in 50 years means it can happen tomorrow. It's 1 in 50.
So sir, as we can, the sources suggest us things, but to safeguard our site, we have also proposed the retaining wall from where the water comes in, so that we, even the landscaping is done in such a way that
Why I tell you that is that because, sorry, I'm interrupting you. Think about it a bit more, because when I read your report initially, you do mention that, there is flood risk as one of the risks in your starting chapter somewhere. Right, and and that is why when I started going into the design, I was almost thinking that you would raise your building up, to protect it further. But that doesn't happen. But towards the end, you've added this wall.
Yeah.
Okay, fine. Now that said, could you tell me a bit more about the maximum temperatures that's happening in the place, right? And for how much percentage time, and what is happening in the non-AC spaces? Because the comfort chart you showed me was AC, right? Because it looked like you were dehumidifying, right? The humidity levels were really coming down. The AC was running.
No, so that was the chart of the throughout. Sorry, that was the chart of the throughout premises, the spaces which were there in the campus.
Okay, because your report has a chart which shows design builder output with temperatures reaching 40 degrees.
Yeah, sir. So we have improvised on that. So we got, so our faculty advised us to rework on it, and we did rework on it, and there was some error from the design builder itself. It was not taking in the inputs, so it was ticking on the HVAC all the time, because of which the temperature was increasing up to 42 degrees Celsius indoor.
Okay, just explain what you have now.
Yeah.
And I think that's an important one in
Yes,
terms
sir.
of comfort and energy.
So, yeah.
Okay, is this average for the whole building you're saying?
Yes, sir. So this is the operative temperatures for the whole premises.
With some having AC, some not having AC. Is it like that?
Yes, sir. some having HVAC. Only one place is having active HVAC, that is the auditorium area. Rest all are completely based on the mechanical ventilation through fans.
Okay, but in this simulation, there is no HVAC running in that auditorium and all that.
No, sir.
Okay, if that is the case, then why do I see this? This is humidity on the top. Humidity levels.
Yes, so that is the relative humidity and the occupied hours.
So horizontal. It's almost as if, you know, between 6 to 7, you know, they are maintaining at 57.5 continuously. That's what I would see in a AC kind of system, right? So almost I think that there is the upper chart shows that AC is running. That's my question there. Otherwise, I would see a spike, right? Natural systems have spikes, right? I will see the humidity up, down, you know, but I don't see that there.
Sir, we'll definitely check on this and get back to you with this.
Yeah, there is something off in terms of the simulation. Ideally, what I would recommend is do one for air conditioning systems, you know, just those 4 or 5 rooms that you have. Of course, they will work well, but you'll get your energy numbers. But do a separate one for your non-AC spaces, right? Because, I mean, go to your psychometric diagram. You know, I can see that there are temperatures which are above 30, you know, peaks are 36, 37. I can't read it, but...
Yeah. The peaks are 35, 36.
35, 36. Yes, the last team that we were talking about, the peaks were, I understood they were 31s. So I was, you know, like, okay, you can get something going with natural ventilation.
No, sir, sorry. There was a confusion. The peaks for the outdoor temperature were 35, 36, whereas the indoor temperature did not exceed 27 degrees Celsius.
No, but see, that's the question, right? You have a thermally lightweight building. It's predominantly bamboo, right? You are majorly ventilating it. Outside air is just moving through. Just think, right? The temperature will be very similar, right? To, in fact, higher if you're not adequately ventilating it. So for all those hours, you know, I would expect, see what happens is, you have a room, you have lights, fans, people, everything happening here. You're trying to get the outside air in. The outside air is about 30, right? 35, let's say. It will be equal or higher. There is no chance of you going below 30 to get your comfort. I am not convinced that you can get the comfort, you know, for those hours. Now, the only question is, how many hours are there which are uncomfortable, which is what I've asked you as well.
So in that chart also, out of which 85 hours are comfortable and 15 being uncomfortable, because those are not operative. So the inoperative 85% is the answer to that.
85% is?
Comfortable hours.
Okay, you say that, but you should probably support it with some simulation, because it doesn't look like that here, right? Because it should raise all the 29, 30 temperature will actually go up, right? Okay, and I also posed you a question, and I think that's not been addressed, is the calculation of energy from your, you know, this wind turbine system, right? Have you gone into it?
Yes, sir. So the question you asked was about like it won't be for 5 months, it won't be 100% time the wind won't be flowing. So we did a cross check for 30%, 50% and 70% of the 5 months. And it is for here we have considered 50% of the 5 months of where the 10 kilometers per hour is available.
Okay, there is, so just tell me, how much percentage of your energy for net zero is coming from these turbines?
17%.
17%. Earlier, I think in your report, it was...
It was 22%.
It was much higher.
Yes.
I think this number will fall down further. I'll tell you why.
Mm.
You have a lot of trees,
yes.
right? Your building is not raised.
So where the wind turbines are placed, the plot beside it does not have any, like it's a plain plot. There's nothing beside it. Yeah. There's nothing blocking.
Exactly. But what I was telling you was that the wind data that you're using is actually measured at 10-meter height. While you need to reduce all those numbers down to
3 meter height. Yes, sir.
And did you do that?
Yes, sir. So you suggested a website for a similar condition, and also you suggested that airport, we should look at the airport data. So the airport closer to Dhubri is at a much higher altitude, so we couldn't do that. We could only trust on the meter data that we had, And according to that, at 10 meters height for 5 months, we have 14.3 kilometers per hour.
So again, individual numbers don't mean anything. You need to get all those hours added up, you know, and then reduced, and then again added up to calculate ki this is my. I don't even know whether the system will work. It's just an interesting idea. But I'm saying is your idea is located at the wrong place. Architecturally, it should be in a very high position to even get some wind going through it. You are putting your screens in front of your building. You know how the wind behaves, right? It comes, it will hit the building, go above it. It will never even come to your. So while you have come up with an idea which is very innovative, very nicely presented, it is not workable.
Okay,
right? And that's my concern. And you can make it workable, provided you go into the physics of it. You'll have to raise it up.
So we'll go into detail of it.
Don't get me wrong.
Yes,
it's a very interesting presentation. Since you do interesting work, so you get more critical comments, right? I'll pass it on and we'll talk more later.
Yes, sir. Sure, sir.
So I think same thing. It was very interesting work, and the way when you have presented is very good. So I have a question with respect to your CFD simulations. It's good to see the way you have done the analysis wherein you are putting both temperature and air velocities together. That's the right way to look about it. But my concern is with respect to what time have you considered for the simulation, because even that matters. Because you can very conveniently take a time which is comfortable, let's say maybe in the shoulder months of September, October, which may not be an ideal way to compare your two scenarios. So it's very important to take a worst case condition where, let's say, the outdoor temperature is hitting very high. So you should, ideally, whenever you do a CFD analysis like this, first you need to analyze the entire year's. You already have it in Design Builder. You can see where the temperatures are peaking, right, in which months. So you can pick the day where the temperature is hitting like very high, and then take that and then do a CFD analysis for that. That's the right way to go about it, because this one I don't know for which date and time you have done it.
Okay, so in the previous report which we had submitted, we considered it to be the default of Design Builder that was in the September itself. But then we rechecked the temperature ranges, and after doing the recheck, we found out that during March to May, we could observe that the wind velocity was on lower side, and again the temperature rise was tremendous, along with the humidity also. So we had considered May as the month while doing the analysis of this.
So this is for May.
Yeah.
Okay, so maybe you should mention it somewhere, and also
Sure.
like aid it with a temperature graph.
Right.
What are the outdoor conditions like? And plus show it for both spaces, which is conditioned as well as non-air conditioned spaces. As even Harsh mentioned, right? For the comfort calculations as well, you should do that. But I think one problem I'm observing in most of the teams is it's very convenient to consider that your building is non-air conditioned, and then you're saying that it's a net zero building. Because it's very easy, right? Your loads, the moment you make the buildings air conditioned, that's where your loads will go up. And then your numbers will not match how much are you generating on site. So I think that's a comment for everyone. I think most of the teams have, like, it's a very convenient thing, right? You don't give ACs, your consumption will be less, and then you put solar panels and you generate more. So I think that's one thing that, like, please consider it. And it's a comment for most of the teams present here. So.
Okay, so in this, so we had done, again, as she explained, we took three cases: the base, intermediate, and the design case. In this, we have represented the base case and the design case. So the drastic difference was in the WWR ratio, as I had mentioned. So that, so when we change the WWR ratio, the amount of air getting in would change automatically. And as it is a humid climate, the idea of getting in more air should be incorporated in the design rather than the coolifying of the air. So in that, what we have done is, we have, for channelizing the air, the bamboo tubes would be helping to channelize the air. And that is how we have done the analysis also. In that, here is the bamboo panels.
You have a room.
Yeah.
You have a window open, and design builder calculates that you guys the kind of speed and temperature, because it's a static simulation. It's at one point.
Right.
That's calculated. Then you do another iteration. You add another room in front of it, literally.
All right.
Right. So, what is the conclusion you're getting out of it? So, I mean, that's the point.
And how come the first space is cooler? It says that it has a lower temperature of 19 to 20, right?
Yeah, so that is the plantation area which we have provided, and even that is semi-covered with the walls, the
So
vertical axis wind turbines
in
which we
base
have.
case, it's not there.
No,
The
ma'am.
plantations are
No,
not
we did
there.
not consider.
Yeah.
Okay, so after adding the component, we added it as a component and not as a block. So that becomes automatically the semi-open area, and that is how we did the CFD analysis.
And that told you that you could decrease the window size. Is that?
No, sir, completely different set of files were taken this, in which, in that area.
You were showing me two simulations, one by
Yeah,
one.
yeah.
You want me to compare them. Is that the
Right.
reason why you put them? So I'm trying to say, what is the conclusion? Why should I conclude that you reach 30% window wall ratio? Because CFD is not about daylight, right? It's not about daylighting. It's about ventilation going through and comfort, right? So what is it? It's showing me at that corner of the room, it's 25
Yeah.
degrees. And
So that is what the analysis was. In this, we can see the orangish. The comfortable range which was provided by the standard was between 25 to 26 degrees Celsius. So in this, we can see the orange ones being in the centric and not very prominent, whereas in this, they are prominent. So a right balance could be observed in the design case as compared to the base case.
okay, we'll talk more about it because I really don't agree on that.
So one last question from my side. If you can go to the embodied carbon calculations, I don't know why you have considered UPVC in the base case and aluminum in the design case.
So ma'am, we wanted to show both, like the unconventional materials which have reduced the carbon emission, and also the materials which are locally available, but yet they are increasing the carbon emission. We wanted to show both the cases, not just the materials which have reduced the carbon emission.
So, aluminum, it's in general used, right? It's a commonly used material when you talk about window
Yes.
frames. So why are you saying that it's a local available material? Aluminum frames are widely used, right?
Yes, ma'am.
Yes, so why is it in the design phase? It has a higher carbon emission. And why did you choose to go from UPVC to aluminum? UPVC windows are also available.
Yes, ma'am.
Okay.
Hey guys, first of all, very good presentation. I'll come back to the comments later. But moving on to your roofing and the solar that you gave, I felt that you were the affordability, the cost that are there a little off. So you are saying that you are generating approximately 25 to 30% more electricity with solar, and you're providing it back to the grid. Am I right?
Yes, sir.
So who's going to pay for that? The cost of the solar panels?
Wind turbines.
So I'm also going to add on to that, but the cost for this, who's going to bear it? And what is the ROI if it is given back to the grid? When will they recover that cost?
So
Think about it.
yes,
So when
sir.
you're proposing like this kind of ideas that are there, just be a little, I mean, it's nice. It's very, this thing, just a small, you need to also understand the cost, because you're saying that everything you're still managing to do within 36,000 rupees per square meter approximately,
Yes, sir.
which is not bad if you can achieve it. But there are a lot of overheads. I think it is the cost that you're looking at. You're not very much off, slightly off in that case
Alright.
when it comes to those numbers. Because in projects like this, the cost of labor, because everything you're talking about bamboo, the material is really cheap, but not the labor. These are going to be very expensive for executing this on site because it's very skill oriented, your entire project. Okay, so you can answer that. You can take this.
So talking about the labor thing, so our project partner is working on the similar lines, that is for the people and by the people. What they do is they build for the community, and they ask those community to build those schools for themselves. So that is the same initiative which we have used. I agree, some of the things required, especially the truss, requires extremely skilled laborers. So again, that is the reason we had considered 50% of reduction. We could have So our project partner suggested us that you can offset 80% of labor cost, but still we kept those 30% as a margin, and we reduced 50% of the labor cost in that area.
Okay, so now on the from the ideas perspective, actually one thing that is really good to see is that definitely on the solar, like when you talk about the calculations for the windmill and all of that, it's off. It may or may not, it definitely will not work. But what I really liked about the overall presentation is that there are a lot of enthusiastic ideas. I think at a student level, that's what we actually also look up to, because it's important to present your ideas, whether they work or not. I think there's a whole life in front of you to explore and see and make them work. But it's really important. So that's what I think I personally enjoyed looking at the presentation, is that it's not one, two. At every, whether it's the turbines or the water, the sprouts that you created, and a lot of and things that are there in the overall presentation that is really nice and very well presented. And I think something I want to add to all the students here is that, when you're actually given a task at hand, especially when you're designing something, you look at it, and most of you, I'm not saying all of you, it's not a general comment, but you look at from the purpose of trying to mathematically analyze the whole project, which is the task at hand, no doubt about it. But in this presentation, what you guys tried doing, which, like I said, is while the performance is definitely spoken about, it's debatable. It's most of your things are can be questionable, but that's one thing. What you tried presenting in the overall presentation is also the qualitative aspect of the school in your 3D and the presentation, which is also very essential, the spatial quality of, you also spoke about the other details, which is actually good to see, and the social aspect, which is talking about so you went beyond the brief. I think that is commendable that you actually went in addressing few of those things, which are also, I think, which is nice to see, because from the, especially from the girl student perspective, I think that's one of the things. But apart from that, you spoke about the food aspect and trying to combine it with the government initiative of the midday meal. And it's a very serious thing, because I know schools and students who actually go to schools only for food. I come across instances where that's a very important aspect for education, and which you spoke about, I think, which is really nice. And also some of the ideas that you're talking about, and presentation, definitely you put in a lot of effort on the presentation overall. So definitely a commendable job on that.
Thank you, sir.
Good. Thank you.
Thank you so much, everyone.
Thank you, jury members. Thank you, Team Lens. We will now take a long break for lunch. We will start the presentation for Team Sun Argon at 2:30 p.m. And folks online, request you to tune back to this channel and be ready for the presentations of the upcoming teams. Thank you. Hello everyone, welcome back to the Educational Building Division. We will now continue with our presentations. One small request, please make sure your phones are on silent. We start with our fifth presentation, that is Team Sun Ergon. They have worked on the Spring Hills International School located in the Noor district of Haryana. Their project partner is Orphans in Need. Team, you will have 20 minutes to present your work. At 15 minutes, I will ring a signal. You won't have a 21st minute, so please finish within the given amount of time. After that, we'll have 10 minutes of Q&A. Please keep your answers direct and to the point. All the best, team. The stage is yours.
Okay, good afternoon, everyone. So we would be presenting on behalf of Team Sanergon, and my name is Tarun. This is Anurag, Mani, and Shan. So our project is located in the Mewat district in Haryana, and the project is the Spring Hills International School. So our site context. So Orphans in Need is a UK-based NGO that has a village close by which caters to around 60 to 70 orphans. So this orphanage is located around 6 kilometers from our site, and our site is to provide a school for them and the children of the community around. So to design our building, it was important for us to read and respect the community, material, and the climate. So here was an interview, but the audio is not available for this, like on the slide. So on this interview, we found out that there are no schools around, like at a certain area. Like you need to walk around 10 kilometers for a school and at least 8 kilometers for a hospital. And it was important for us to create this school that also acts as a community center that provides girl-child education. It has a public health facility, healthcare facility, and a sports academy, and provides vocational training. And so coming to materials, our site provided with earth and quartzite. And we chose to use these materials to our advantage because they're purely natural, they match the local aesthetics, and they're efficient and eco-friendly. And for climate, we've analyzed it through psychrometric charts, use sun path diagrams to find out which side gets our radiation, which side of the building gets the most radiation, and our occupancy profile and others.
Let me start with our approach, which is based on graded response to different seasons. First, reduction of thermal load and providing heat sinks. Second, high UDI and low LPD. Third, low energy passive systems. And fourth, high efficient active systems. And finally, on-site renewable energy to become net positive. And now for the specifics. Shading of indoor spaces from the east sun through corridors. Horizontal and vertical shading for our facade, which has the maximum exposure to heat gain. These shading techniques allowed us to achieve a UDI of over 90%. Coming to the LPD, we have super low LPD at 4.1 watt per meter square using efficient BLDC fans, which are 62% efficient. Coming to our envelope values, we have very low U values ranging from 0.312 watt per meter square Kelvin and 0.22 watt per meter square Kelvin for our wall and roof module respectively. And we also incorporated green roofs, which help in reducing the heat gain. Finally, we also have heat sinks, which work through earth. Basically, for earth, we have our ground-coupled radiant slab and AHU heater, heat exchanger, which enables us to use earth as, as an element for our heat sink, and then sky irradiation to cool the kun at night for our indoor cooling. Finally, water for outdoor spaces through evaporative misting, and we also have trees and vegetation. About the passive system, a combination of natural ventilation and ground coupled radiant slab and AHU exchange heater. About the active system, we have a B double 5-star water cooled heating pump and with a COP rating of 5.5, mainly to meet the latent fresh air load using during extreme hot, humid and cold seasons. Both the heat pump and the ground coupled system work together. And this sums up our journey to reducing our EPI from 155 to 37. To become net zero, we needed 338 kilowatt solar PV, but as net metering is an option available in Mewat, and we also have the available roofing area, we installed a 400 kilowatt solar PV system generating 5.8 lakh kilowatt per kilowatt hour, becoming net positive by 16%.
Okay, for architectural design, so we start with the tree as the epicenter. So for us, the building emanates from the tree because the tree is like located over there, and all our blocks start from there and go over. And we're using Stuart Brand's concept of shearing layers for our construction. So initially, we had our massing is. Our massing is like it was important for us to open the corridors to the streets outside to provide more community engagement with the school. So we started making a layout around the site and raised the mass. Then we realized that we're receiving a lot of radiation from the east and the south facade. So then we provided corridors on the east, and on the west facade we've only provided came up with sharing devices. So this is our site plan. And on our site, we have 4 main zones. So one is the academic zone that is around the central block, and 2 there's a central block over here that caters to all the activity spaces. 3 this is the recreational zone that has a multipurpose hall and an OAT, and this is the field and the services area. So talking about spatial efficiency. Our activity spaces such as dance, music, and art classes are located here, and our library at the center. All our classrooms are around here, and they are connected with a network of bridges and bridges/ramps to achieve efficient circulation. And our central block is located minus 1800. It is in comparison to the other blocks, our central block is lower by 1800 mm. And this allows for us to provide bridges that provide accessible sloping. And coming to the facade details, it was important. Okay. Our modular brick facade is made of compressed earth blocks along with an insulation layer comprising of hemp, lime, surki, and rice husk. This insulation is made to added to reduce the U value of the wall envelope. And there are 2 kinds of modules on our brick facade. One is one that provides horizontal shading, which is the module A, and module B provides vertical shading. The process of construction is also mentioned here, starting from excavation of earth till key steps such as collecting, curing, setting bricks, and then making the modules and placing the modules according to the windows. So our class module is, the explorer view of the class module shows us how the installation and our vaulting system that supports the floor slab is coming together. So we have CSEB thin tiles with PEX pipes on the top of on top of it with installation of hemp lime, surki, and rice husk. And these are all supported on inverted T-beams and on CSEB columns. So our bridges are built to So similarly, CSEB walls of 2 inches are used to create timbral vaulting for our bridges. And these bridges are integral part of our design because it promotes universal accessibility and thus reducing the dependency on the staircases. Although we have also also abided by the fire norms and placed the staircases around the building.
For our rooftops create a multi-level space which promotes interactive experiences with nature. And coming to our landscape design, here's a glance of our building where we have different properties and interior spaces, such as the rooftop area, the classrooms. We also have a public health center, which again brings in the community aspect. And then our boundary wall is also designed in a way where we have drinking areas as well as seating areas on both sides of the wall to invite the community and to make them feel that it's a part of their area. And we also have timbral vaulting for our bridges, like Tarun just explained, and the multipurpose hall, a cafeteria, and library. For landscaping, we decided to have a very holistic approach, which was done using all local species and keeping all the birds and animals in mind. And we used undulations as a tool to create interactive spaces in the landscape, like our play area and so on. And furthermore, our site will also be inoculated with mycorrhiza, which not only helps in reducing the carbon in the atmosphere, but also creates an underground system which helps in nutrient transplant, thereby making all the trees much more healthier and immune to diseases. And finally, we have mulching, which uses the agricultural waste on site to further grow the plants.
So moving on to water performance, we wanted to incorporate a very holistic caring plan based on rainwater, soil investigation, and groundwater quality tests as per IS 10500. So our goals were to minimize the indoor and outdoor water demand using low flow aerators, fixtures, and talking about outdoors, using xeriscaping and drip irrigation techniques. Second, we wanted to incorporate 100% usage of rainwater on site. Third, 100% recycling of black and gray water. And fifth, we also had provisions. We were ending up with some surplus water after all this process, which is about 2,796 kiloliters per year, which can be used by the community seasonally or can be sent back to the groundwater table. So moving on to embodied carbon, our goals were to maximize recycled content in the materials that we are using, minimizing the high embodied carbon materials such as concrete and steel, minimizing transport and sticking to the local materials that were offered on the site, maximizing clean energy through the use of solar PVs. So because our site has a composition of 75% sand, we just need to transport around some quantity of cement, lime, and sand additionally in order to make the CSEB columns. So and then in the end, we managed to achieve a total reduction of 55% from 3013 to 1289 kilograms per CO2 per functional unit area. Then moving on to resilience, our site belongs in the zone 4 category of, according to IS 1893. So our buildings were earthquake resilient and it followed the IS code 1387. Moving on to water, we uh, we through a conversation with our expert, we created a kund to store the excess water, that surplus water that we were coming up, that could be used by the community, and in case if there was excess rainfall. And then moving on to climate change. So our design was, we were extremely serious about imminent heat stress. That's why we had ground coupled system with provision to adding active heat pump if needed. Then moving on to building autonomy, we generate around 170 to 190 kilowatts of energy per day, and our entire water cycle is self-sufficient. Health and well-being.
Coming to health and well-being, we followed ASHRAE Standard 55 2010 for our thermal comfort. So our approach focuses on reducing the number of unmet hours, and in order to do so, we refer to the psychometric chart and to the PMV model. So 1352 is the total amount of annual occupied hours. 1282 is the total annual unmet hours, taking the cooling set point at 26 to 30 degrees Celsius and heating set point at 12 to 18 degrees Celsius. 29% of our unmet hours were reduced by high performance passive strategies like envelope through solar shading, low U value, and high thermal mass. And 39% was reduced by passive systems like ground coupled radiant slab and ground coupled AHU heat exchanger. This is applicable for non-extreme summer and winter climate. And finally, 32% unmet hours were reduced by active system using heat pump for cooling, heating, and dehumidifying. This is applicable for extreme hot, humid, and cold environment. And all of this reduced our annual unmet hours to 144, which is well within the 80% acceptability range as per ASHRAE 55. For ventilation, we used fresh air ASHRAE 62.1 and NBC 2016. And for IAQ and AQI, we refer to ASHRAE 62.1 and ISO 16890. Air filtration standards were followed. For indoor spaces and for outdoor spaces, we have misting.
Moving on to engineering operations. So starting with the structural systems. So since we are trying to reduce high embodied carbon materials, we have designed structures in such a way that can incorporate the materials available on site. The plumbing systems are designed in such a way that they are right size and complete the entire water cycle that's needed in our design. And moving on to electrical systems, we have aimed at using highly efficient electrical fixtures with, speaking of lights, such as lights of a luminous efficacy of 116 lumens per watt, while also maintaining 300 to 500 lux level as told by the NBC.
Now coming on to innovation. Innovation for us is a process of creative destruction. So we have here tried to solve two problems, starting off with limited application. We have created innovative design possibilities in earth like rammed earth wall, customizable CSEB earth blocks, interlocking CSEB blocks, CSEB columns, walls, and roofs. Number two being slow construction
speed and high labor cost. So we have used a combination of machines like pneumatic rammer, or Impress 3000, or Impress 5000, which has helped us cut down our cost and construction time. Also helped us have efficient strength and is environment friendly. The third being scalability and brick projects application. We have a site planning and management through a construction phasing and planning of spaces for processes like excavation, storing, and execution of the earth construction, which helps in the site preparedness. We also have a construction planning and management done through detailed Gantt charts and project construction timelines, starting off the construction on site from the front block, moving on to east block, west block, central block, and finally to the multipurpose hall. So our innovation is not just about design thinking, it's about design detailing, and not just about design detailing, it's about design execution on site in reality. And this method of thinking, designing, and building is what makes our project affordable. So coming on to the values that we provide through our project, number one is that of environmental value. We have cut down on the operational energy cost by reduced carbon emissions and reduced embodied carbon. Economically, we are able to cut down on the operational...
Sorry, thank you team. You gave a very insightful presentation. Let's take the jury comments and then the questions.
We just have a walkthrough left if that's possible. Yeah.
No, we've finished.
Hey guys, thank you for the presentation. I have a few questions. I'll start with the site planning. What you did. It's understandable that you took the profile of the site and offset it for getting the maximum efficiency for the buildings. Correct? Because your buildings are mostly positioned on the periphery.
Yeah.
So from an orientation standpoint, how does it stand? Have you tried through analysis to check if that is the right way from a performance standpoint? Have you checked any other typology instead of this approach?
So we did have initially we had designed a one straight curvature like a form, but we had removed it because it caused a lot of radiation on one side of the surface. But then we realized having this the shape of the form of building, it gives us, like I mentioned before, it gives us accessibility to the outside, to the community. So if there's like a children studying there, and if you want to go across there and you can see them studying, it's also a vocational training center. So it's so we want people to engage with the site and not just stand apart. So that's why the periphery is important for us.
Yeah. Like I said, from an efficiency standpoint, I don't question this at all.
Yeah.
From a orientation and the sun solar radiation perspective, the orientation of the blocks, because I thought that this is straightforward. This is there. So I was just wanting to check what was the thought behind that.
So we try different orientations, and we have a report of the simulations in our report as well. But the reason why we ended up with this orientation was because there were several factors, like primarily the client requirement. The client wanted like a central vista, like a central axis, and also he wanted like a grand appeal to the whole building. So there are some trade-offs while we made in designing, and moreover, going for this orientation helped us coming with that very innovative facade, which does have its own unique value, selling value. So
that's my next question, actually, your facade.
Okay.
Definitely, I mean, no doubt that is interesting, the parametric facade that you did. And I think that's one of the questions also that I asked you in the report, is that was there any analysis done? Because when you talk about the overhangs, now when you look at the facade, that's what was the logic behind what is the overhang that is there and the wall that's coming in? Okay. Have you done any also because it's also creating an interesting pattern for mutual shading of sorts, because each brick casts shadow on the other one. So is there any form of evaluation that was done to understand its performance? Because in the window there is nothing. Correct me if I'm wrong.
Yeah, no.
So why is it so? Why not? I mean, having while having a window with shading and also this. So
okay, first of all, this should not be called as a parametric facade. It's a modular brick facade. So each module, it has a curvature that corbels out on the top. Like if there's the ones that provide shading, at least they have a corbelling at the top. So and our brick size is 300 by 300 mm, and it has 100 mm height. So the can I go to the slide? Yeah, so our cobbling is done similar to how the arch vaulting is done, and so there is also like a horizontal steel rod that is running. Five, yeah. So over here you can see this is the one brick module, and we'll have horizontal steel beams running here, and vertical like steel, sorry, not steel beams, steel rods. So whenever there is a window, something like this, then we'll have a like the protrusion coming out, and the steel rod will be supporting it. And also we have the filler inside, right? So that filler will also hold the brick facade together with the wall behind it.
Yeah, I mean, so that's where I'm actually heading to, because one is this cantilever, there is a strength and the center of gravity of the wall, the brick. If you tilt it even further more, it will fall off. It's not structurally stable. So you introduce steel for that to get the strength.
Yeah.
So which adds again to the embodied energy.
Yeah, this has been included in our embodied carbon.
In this thing. So like as an idea, like what I'm saying is that this is very interesting as a facade treatment, no doubt about it.
Yeah.
My question was mainly on, have you done analysis to understand what is overhang and what's the performance of that? It's very, so it's from a, so what I'm asking is that, do you know how effective this is? That's.
So can you repeat, like effective in terms of?
Can you tell us how effective this envelope is from a analysis perspective? Have you done any analysis to understand this facade as a treatment, because it's coming on the south?
Yeah.
Correct. So you are saying that.
Yeah, like thermal calculations have been done on this, and the reduction. So there is like a, so this is like a 600 mm thick wall. So there's a massive thermal reduction in that side of the facade, and the overhang for our windows are like that 600 mm width. So.
Sorry, just to add on to what he's saying, so this requires for us to make a prototype which will be done on site, because most of our construction is done on site. So there will be a prototype which will be made on site, which then will give us the actual testing that you're asking for, like the quantitative numbers, which will be so, but the facade in itself is like, it has lot of cultural value to it as well, like we're incorporating the community.
No, the design is brilliant. I'm not questioning the design. It's only, if I take a typical window with overhang, I can calculate that with this kind of overhang, I can cut this much of sun. So that's, okay, I think you understood the question. Let's go on to the next one, because of, yes.
So when we were designing facade, the overhangs were considered. Even with the facade, we had placed overhangs, but when the entire system came out, we realized the overhangs were not required, because the maximum shading that we are getting is 600 mm. So overhangs were not required. In our design builder, we had run simulations with the overhang as well.
Okay.
So
600 is good enough for you, is what you're saying?
Yes.
Is good enough, 600?
Yes.
Okay.
The facade was working out when this simulations were
okay,
run.
we will also look into that, but since due to the shortage of time, I'll just move to the next question and I'll pass my comments. The last question that I have is, all your work is based on rammed earth and CSCB and all of that. You did speak about in the presentation about the earth and the soil is a composition of earth and quartzite. But then typically when you're making such a big decision, it's very important to understand the soil. What is the typology of the soil? But that was not actually there in the report earlier. So can you give us just some insights about what is the soil and whether it is actually good for this? And you also spoke about you're adding certain compositions to make it viable for that. If you can just talk a bit about that, I think it'll be great.
So I'd like to go back to that slide where you added that pie chart. So our average site soil composition on site is about 75% sand, 14% silt, and 10% clay, and the rest 1% gravel. So this is up to the depth of 3 meters, which will be the depth that we'll be excavating for our foundations also, and the soil that's going to be taken for our rammed earth and CACB building elements. So we were during the conversations with our engineering partner, he said that this site soil composition on site is actually very good because it has quite a good amount of sand in it, 75%, which is needed in our engine, in our design. So, but some additions of cement and lime were to be added in it, so that to make the structure a little more stronger, just to add a little bit of strength to it, because the CACB columns will be taking a lot of load. So that's why these two things had to be added to make the CACB.
What's the soil typology on ground?
Yeah, sandy silt.
I think you guys are quite hardworking. I can clearly see that you have taken up the challenge to deal with certain techniques which are quite complicated. Let's say the ground source heat pump is not an easy thing to work with. But still, you have taken up the challenge to integrate these kind of systems, including even the radiant cooling coils and all that you're trying to put up in your systems, which is quite good. But firstly, my question is with respect to, I saw that the radiant system is integrated with a CSEB thin vault panel. Like there's a thin vault, right, that you have put up. But radiant panels are typically, if it's not operated properly, it's quite prone to condense. And once it condenses, it will have a lot of problem in your rammed earth wall that you're providing. So how the system will be able to tackle this?
So since we are using a ground couple system for our radiant cooling, so that system in itself helps in that system in itself helps in reducing the conduction because the water is coming from underground, and moreover we also have an insulation layer between the timbral vaulting and the slab, so that prevents like whatever cooling effect is happening, it prevents it from rising up and actually through conduction and then radiation to reach to the classroom and provide the required cooling. Yeah, the exploded diagram.
Because I think that insulation is above.
Yeah.
Then your cooling coils are there,
Right.
and then the earth vault is there, right?
Right.
So when the condensation will happen, it's directly going to fall on those panels. You see this section
Right.
below
Right.
the radiant pipes. When they condense, the water is going to fall on the CSEB thin tile vault. Fine, and that's something that you need to watch out for, because that material composition, can it withstand? First of all, you need to understand, would it condense? And it also one thing that that's why I think one thing, there's a big gap in your studies with respect to analyzing the climate. I didn't see that external climatic conditions. What are the temperature levels? What are the RH levels? It's important to see that. Plus, what is the indoor RH that you are trying to maintain? Because that will have an impact on the condensation that can happen on the pipes.
Right.
So think through it. I mean, you don't need to answer it right away, but because again, it's a complicated system. It's good that you have thought of it. At an ideation level, it's very good, but then practical implementation, think of it from that perspective. Then the second point is on the rammed earth. I think it's one of the, again, it's a great feature of your design. In fact, internally, we three also discussed quite a lot about this thing. And my opinion is that the profile that you're providing right now is very thick. I think it's 300 plus insulation plus 100 mm, right? So if you see the overall cross section of wall, it's really thick. And if you calculate it from thermal mass perspective, it's a very high mass. It's not a general thermal mass that is being provided in the usual construction building. So you also need to understand that a very high thermal mass building is not always good. And especially for a climate like it's close to Gurgaon, right? Because for your exact city, I don't know if you will get the climate files, but for Gurgaon, you can at least have the climate files for that, right? Winters are going to be quite harsh. And these systems, they will retain a lot of coolth. And this will again make the inner spaces even more cooler. So that's one of the point that you have to tackle when you are dealing with rammed earth. It's not, so one good thing that I see is you have included insulation in it,
Right. I think in your report it was not coming out clearly. This cross section you've put in the annexure.
Right.
I think this one, this for
The
this wall,
facade,
right?
yeah, yeah, yeah.
So it should come up in the main section that was missing.
Right.
So now only I'm seeing that you're providing insulation. Otherwise, I was going to suggest you to integrate thermal mass with insulation,
Right.
because these two, like if you look at it from building physics perspective, they work very differently, and you need to put that into mind. I don't know how have you simulated this. It's a big question mark to me. Like the wall is, like, did you take cross section wise, you took a cumulative U value and then you did that, or what was the method for that? You took like multiple cross sections and then calculated the U value for that. And I hope you have also considered the density and the specific heat capacity of the material. You have? Okay. Because that will handle your thermal mass part.
Right.
If you only use the U values, it will not give you a clear picture
Right. So
of how
for the thermal mass, and you mentioned that in winters if the building cools down a lot. So because of that, we try to sort of address that through our HVAC system as well. That's why we have a heat pump which will be connected to our ground source system. So in case like during winters, the same system will be used for heating and warming up the space as well. So
that's fine, but that's more like an active system, no?
Yeah.
I'm talking from passive system perspective.
Right,
it's like you are like overloading the system because it's becoming so cold. Like
Right.
why would you want to heat that? So that's why a combination of insulation and thermal mass it's a very complex subject, by the way. Nobody understands thermal mass that well. And we all feel that thermal mass is very good, but that's not the case. I mean, it needs to be optimized. Okay, so I think this is it.
Firstly, I think very interesting presentation. I think your report wasn't conveying it as well, but I think a lot of the ideas are coming across through the better use of all the images that you've done now. Wish you had done some of it in the report as well. Now, I'm trying to, first I'll try to understand some things, because you are talking about quite a few complicated systems, and I presently have not understood how they try to work together and what you're thinking on it. So in your report, you mentioned this radiant system, right, which is linked to the ground, and you are, getting cool or hot water, probably putting it in. You also mentioned that the classrooms are supplied with some kind of air system.
Yeah, so we also have an AHU system which will providing fresh air and also dehumidification whenever required.
How does that happen or do you have a section?
Yeah.
Where is that system? And okay, so I saw this. I could not fully understand it. The diagrams are not very clear. But what I will ask you to do is, tell me, how does a classroom work on a typical summer day, right, when the students, and a typical winter day? So which systems come on and off during which times of the day? Start with summer.
Okay. So in summer, I'm going to address the extreme summer.
Yeah, just peak summer day, very hot summer day.
Okay. Yeah. So then basically our ground coupled system will be working in tandem with our AHU. Like we have a heat pump which is attached to our ground coupling system, radiant system, and that heat pump will basically will help in circulating it will help in so we have a heat pump which is connected to our ground source ground coupled system, and it will basically circulate cool air, and it will help in condensing in conditioning the space. And now we simultaneously we also have the AHU system working, which is providing fresh air to our classroom unit. And in a typical winter day, we have again the heat pump, which is going to be providing hot air through the radiant, through the pipes that we have, and it will help in, so we also have a set point from
So does any of your friend want to, jump in? Because you got a bit confused with both of them.
So basically, our HVAC system during the peak summer days is that we already have the radiant slab, which is taking water from which is taking geothermal property heat from the ground, and which is going to be going through our chilled ceiling. And for the summer days, we have the IHU coupled with the water-cooled chiller, which will be supplying air conditioning in the rooms in the peak summer days, which is throughout the operation hours. And for winter days, we have the heat pumps, which is also connected to the fan and coil units. We have the heat coil within that, and it's gonna provide the the heating for the room in the winter periods.
And you, I understand it, and I think I agree with you. But just could you explain it a bit why you opted for the dual AHU system? Is it only because of getting to the right temperature, because your radiant system doesn't have the capacity to kind of cool it down?
Exactly. Only the radiant system, we're not able to get the met hours.
Right.
So we added and also for dehumidification, and in the hot dry season, we're not able to meet the thermal comfort. So we added the chiller.
All right. Okay. Have you thought about, maybe you did mention it, but all of this, because you're using multiple systems,
right.
Are you thinking of it all being controlled by a BMS system and then sensing, what's happening in the classroom? Because, for example, maybe, for certain months, in winters, maybe you don't need the heat pump running, right? And it's transition months, November. So it's not cold enough, it's not hot enough.
Right.
You don't need to do anything. How do you sense that? What's your BMS strategy? Have you thought about it?
So mostly we haven't gone into automation. We just gonna do this through manual operations. So that's pretty much that we're gonna do right now.
Okay, so I think that's an area I'll recommend that you think into.
Right.
Because whenever you have multiple systems, you need some controls. Obviously,
exactly.
Facility managers running around and checking, what's happening is not the way forward now.
Right.
Maybe some sensors detecting, and also some, you can program it, based on your
Right.
simulations.
Set points.
That a general comment. So I got the system now. I think it's good. I wish you had explained it like this in your reports. So the report was, very tough to read.
Right.
A quick comment on, your architecture bit of it. I think it's a very interesting approach you've taken. I totally support, use of earth. I think it's the future. It should be the future if it's not, because of its value in decreasing the carbon and the carbon impacts. However, when I look at it, despite everything, right now it's become a bit monotonous, right? Because you're using the same, two modules everywhere. I think what needs to happen is your modules need to start getting controlled with orientation and also with the function that's happening inside. So maybe at some point they only go 300 mm outside, 450, and everything doesn't need to be 600, and the same. That's one. Second thing I really thought about was that I thought that two different people designed the ramps. One designed the ramps, one designed the buildings. Is that because totally different structure system, thinking about it, the vocabulary, the architectural vocabulary doesn't carry inside at all. It feels very different. It's interesting, but it's very different. So, you can react to it if you want.
Yeah, I'll give it. So initially we even had thought of vaulting structures on the corridors, like that it's facing into the courtyard. And we were like, okay, yes, we'll merge that into the vaulting and it'll look seamless. But then just designing these walls were really intensive for us to come up with a model, and then setting up the right sizes for our vault, width and length. So then we couldn't get that in. We had already thought about it.
I just wanted to take up the answer where we are talking about the two modules that are being repeated. So one, there was a reason why we were repeating the two modules is so that we are able to make it faster. Like creating a facade like this is a huge task of labor and everything. So through these modules, is a compilation of a modular facade. So these modules will be compiled near the wall location, and then they will be placed together using crane systems and everything that we have worked out. So also this wall is only present on the south facade and a little bit part of the east facade, southeast facade, and on the west southwestern facade. It's not used everywhere. On the all other facades, we have rammed earth wall with the insulation biscuit.
Okay, all right.
So,
So all the
yes.
inside will be probably plain.
Yes,
you
and
know,
our interior walls are CACB interlocking walls that have voids. So those are all our other systems. So we are using 3 type of walling systems. We are not, the facade module is not just the one module that is being used.
Okay, I heard evaporative misting. In what context do you? I mean, that's the third system. Where are you wanting to use it and why?
So we're using it for outdoor spaces, primarily outdoor spaces, and it's during summers and like extreme, like when it's too hot. So it's to provide like cooling, like because we also have a lot of landscape elements. We have a rooftop garden and a lot of public gathering spaces. So that's why that's the only place where we're going to be using evaporative.
Okay, so I mean, I don't know whether you have accounted for all that, kind of water, in your water calculations. Have you been able to, guess estimate at least something on that?
Yeah. So in our, if we move on to the rainwater thing, water performance. One second. So in our water performance, the water for cooling 1426 kiloliters. So around 40% of it will be for these cooling towers for when they're being used. So we accounted.
Evaporative cooling towers.
Yeah, yeah.
Okay, and all of that happens inside the courtyards, is it?
Yeah.
Primarily near the courtyard.
Okay, all right.
I just forgot to answer one of your questions. That was the bridge structure and the building structure in terms of architectural elements. They are not entirely different structures because our bridges construction is being used using the quartzite stones. We are using the rammed earth wall, and we are using the CSCB block. So if I go to
Yeah, show me some images, maybe I can understand. I think what I really like is you have a lot of interior shots where I can understand, what you're really talking about, and that's good.
So if you don't mind, I'll just come here. So if this is not very clear on the projector screen, but the piers are made using the quartzite material
okay,
that is
all right.
also being used in the entire building process.
Right.
We are using it in our foundation as well. And our support system is using the rammed earth wall. The arched connections are again using the quartzite, and then we are filling up the timbrel walls with the CSCB block. So we're using the same building materials that are being used for the main building as well. So it's
Yes, I of
things.
course got the point that it's
Yeah.
same material. It's just that even if you look at this image, my point was more, architectural.
Right.
I think in terms of how it feels, But it's good that you explained it because I did, in your renders I couldn't make out that you're using multi-materials to bring those ramps.
Yes.
It's just a comment,
We can
it's
work
your
on it
architecture. You have to
further.
think about it. My comment is that the ramps look very, not integrated presently. It's a good idea that it moves, connecting the building, but architecturally the shapes and the, because see, you don't have any, similar elements, curved elements anywhere on the outside, right? I just thought it was very jarring when you come in. You may think it's very interesting, so it's up to you, but that's just a comment. That's it. I mean, any of your thoughts, Otherwise, that's it for me. All right. Thank you very much.
Thank you
Very
so much.
interesting.
Thank
you.
Thank you, jury members. Thank you, Team Sun Argon. Let's begin with our sixth presentation. That is from Team Vinaya. They are there, right? Team Vinaya? Yeah. They have worked on the Gyan Pramodini School in Pune. Their project partner is Gyan Pramodini Prashala. Team, you will have 20 minutes to present your work to the jury. At 15 minutes, I will ring a signal. You won't have the 21st minute, so please be on time. After that, we'll have 10 minutes of Q&A session. Please keep your answers direct and to the point. All the best, team.
So, good afternoon, everyone. We are Team Vinaya, presenting Enlightening Spaces, a holistic education campus design for Gyan Prabodhini Prashala, Pune. So, climate change is a cross-cutting issue. If we don't act now, climate change would reverse the progress which we have already made in working together for our planet's prosperity and peace. So, Team Vinaya, consisting of students from Dr. Bhanuben Nanavati College of Architecture, Pune, and Indian Institute of Technology, Bombay, propose a school building for the new branch of Gyan Prabodhini, which would support in achieving sustainable development goals as highlighted over here. So, taking sustainable campus planning as an approach while following the codes and project partners' requirements along with climate and resilience studies, providing sustainable energy and environmental solution, our team aims to provide a net zero building. Based on the 10 contest criteria, we have divided our whole design process into 10 categories as shown over here. So, Gyan Prabodhini, meaning awakener of knowledge, is a social and education experiment working on foresight development of each student, that is, the individual, the intellectual, the emotional, and the motivational. Gyan Prabodhini has various activity spaces, along with which Gyan Prabodhini strongly believes in spirituality. So daily prayers are conducted in a prayer hall called the Upasana Mandir. The school facility is based on the early Gurukul system. So we aim to provide a CBSE residential school for class 5th to 12th standard for girls and boys. Some of the special requirements of the project partner included to provide a design solution with a response of vernacular architecture using modern technology, but not forgetting the old values, to cater different types of users, to provide to provide an interesting learning and teaching experience, and to provide a dedicated prayer hall, which is the Upasana Mandir. So, to understand different types of user groups, a service was conducted for between the principal, teachers, and students of the school, resulting in understanding of the daily schedule of a student described over here. And while the working hours of the school were mainly from 10 a.m. to 5 p.m. Now, as the site is located in Pune, understanding of the climate is essential. So Pune comes under the warm and humid climatic zone with an average rainfall of 722 mm and having dry bulb temperature ranging from 18 degrees to 32 degrees Celsius and having relative humidity from 42 to 85%. And the major wind direction is mainly through the west. Now, talking about the site. The site is located in Bavdhan in Pune city of Maharashtra, India. It can be accessed through Pashan Bavdhan Road and Poud Road, connecting the NH48, having a plot area of 56,000 square meters. The site surrounding mainly include Pashan Lake on the north, Necklace Garden on the northeast, and Arai Hills on the east. After doing the SWOT analysis, we understood that the site has scenic beauty, the site has scenic views and biodiversity as it is adjacent to the hills. The neighborhoods are mainly residential and mixed use in nature. There is no public infrastructure for the pedestrian and the access roads are narrow. The site has a vast expanse, so there is an opportunity for horizontal expansion as per the sustainable site management and scope for designing user-friendly spaces considering the natural site context. As the site is adjacent to the hilly areas, it is subjected to wildfires.
So, as Unnati mentioned about the 10 contest criteria, our first contest criteria is energy performance. We have performed several simulations to optimize the energy performance of the building. Passive design strategy is use of proper shading devices as per the orientation and considering the UHIE for the design response is considered. We have also performed radiation as well as for the sonar analysis for our design cases. And amongst these 3 cases, the case 3rd performs well. Strategies like dispersed building design, staggered block arrangement, wedge-shaped building design helps to enhance the wind flow across the site. This understood by doing CFD analysis. Now, for the shading analysis, we did parametric studies and we concluded that the option 3 and 4 performs better with an overhang of 600 mm and with the operable fins. So, to cut down the glare on the southern and the western facades. Now, talking about the envelope design, we have proposed for the design case against the ECBC baselines, where the U value for the wall is 0.78 watts per meter square Kelvin. For the roof, it's 0.44 watts per meter square Kelvin. And for the glazing, it's 1.87 watts per meter square Kelvin. So the graph over here shows the EUI breakup for the base case against the proposed case. So for the lighting, reduction in the 50% is done due to the space by space method. For the equipment, the reduction is done due to the recommendation of minimum 3-star BE rating equipment. And for the HVAC, we have proposed a VRV system for our design case. So the overall 65% reduction in the EPI is achieved. So now talking about the renewable energy, we have used mono PRC half-cut bifacial panels with an overall capacity of 340 kW, which annually gives around 5.1 kWh annually against the consumption of 3.3 lakhs kWh, which makes our design net energy positive. To satisfy the hot water demand, 3,800 liters, we have installed 25 evacuated tube solar hot water system for the design case. So now coming towards the architectural design, interactive learning spaces have been designed for the passive design strategies, enhancing biodiversity of the site, creating pedestrian-friendly linkages, and then the user-centric design approach was considered. Separate blocks are designed for the administrative, the academic, and the residential needs. So the separate learning spaces for the girls and boys are developed with the common lab area on the top floor, which is second floor, and which will be connected by bridge on the top. So design is done keeping in mind that the prayer hall will be the focal point of our design. Upasana Mandir features some sloping roofs, then the verandas and the smaller inlets, which is inspired by the Vada architecture. Separate activity blocks are created for the extracurricular activities with the flexible interior layouts. Then the interactive spaces like semi-open amphitheater spaces are created with the green pockets are inserted, which will act as the informal gathering spaces. So now coming towards the embodied energy, a careful selection of material is done after the extensive market survey. By designing BOQ, considering lower GWP materials for our design case, and doing LCA, which will give the unit-wise emission to achieve around 80% of the reduction from the base case. Then by applying the strategies like use of local materials with the recycled content and the simpler manufacturing processes will reduce the embodied energy.
Okay, so coming to resilience and durability. So resilience and durability is one of the vast topics that can be covered in many ways. Here we have tried to adopt an active approach, that is assess the risk and withstand the hazard. then when possible, resist them when necessary, and then mitigate them when needed. Coming to this, by doing a primary environment impact assessment of our site, we found out high risk and medium low risk factors of our site. Since Pune lie in zone 3 of earthquake, so we have done our structural design based on that, integrating shear walls and then also having the shallow footing with raft foundation. So since it's becoming more frequent that the heat waves during the summer season, so we have tried to adopt some UHIE mitigation strategies, such as providing this minimizing the hard escape areas, then also increasing the grass pavers and vegetations of native plant within the campus. Pune lies in moderate to heavy rainfall category. So the designer of the buildings have tried to incorporate stormwater management system so that they can avoid the risk of flood in the site. Also, we have integrated rainwater harvesting system with some recycled water system to satisfy the water demand and also to use the rainfall of the area. Coming to the wildfire, to avoid the wildfire, we have provided high walls with fence so that we can protect our campus from the wildfire thing. There's some medium to low risk in terms of energy and water shortage. So the campus has a grid integrated PV panel system that can provide you the electricity in terms of renewable energy, and also as a backup it has a biodiesel generator which can provide electricity in case of grid outage during the night time. So for the water system, we have a rainwater harvesting system integrated with which is able to provide the sufficient of the demand which is there in the campus. Also, in terms of grey water recycling, we have provided a grey water system which uses that water can be used as flushing and the agriculture part. The site has a for the waste management, we have a strategic planning which is done at the site level itself. Coming to engineering and operations, it is one of the integral to understand the structural integrity of the building. By analyzing existing soil and understanding the soil bearing capacity of the site, we have designed a structural system of the building. Raft foundation with a shallow column footing, where shear walls are constructed for the services like lift are proposed, and so that they are able to withstand the forces and loads of the building itself. Now coming to the NBC norms, the NBC norms are considered to ensure that the building can withstand its essential uses and potential hazards like earthquake and other. For the Upasana Mandir, which is one of the focal center of the campus, we have given a truss system for pyramidal slope roof to go for columnless and easy to construct technique. A waffle slab of 300 mm is recommended for auditorium below Upasana Mandir for the long span without making the system more bulkier. Talking about mechanical part, so for the occupant comfort, designing of a right size of a mechanical system is essential to reduce the uncomfortable hours within the indoor spaces. So here for our design, we have proposed a VRV system. System which enables which operates when the space is under occupancy. Now the indoor unit are ceiling mounted cascade system which can provide a 360 airflow discharge in all the direction. And as per the technical details, this Daikin VRV system has an overall COP of 4 with a fan efficiency of 70%, and overall this system is able to reduce the energy consumption by 38%, that cooling energy consumption.
So health and well-being is established for the occupants by providing visual connection with the outdoor spaces, designing openings as per summer and winter sun angles, reducing heat gain by using cavity walls and insulation materials, and daylit classrooms with cross ventilation. All the classrooms are designed and simulated in light stanza, resulting in 600 to 900 lux of illuminance, with 57% of the classroom area has more than 300 lux of illuminance. All the multi-occupied spaces were simulated at the ventilation rate of 0.12 CFM per square feet, resulting in the provision of mixed mode building type with 2 hours of mechanical ventilation to satisfy the fresh air requirement. Inclusive design, tobacco smoke control, and application of no VOC paints further adds to provide a safe and healthy environment for the occupants. Insulation, cavity walls, natural sound barriers like vegetation to cut off major sound disturbance and reduces the reverberation time. So water performance, efficient water performance strategies, use of water efficient fixtures which give 40% of savings, efficient irrigation system which gives 62.5% of savings, rainwater harvesting is done and 100% of wastewater is recycled. Water metering helps to monitor the overall water performance and thus reduces the demand of water from municipal corporation. The water cycle diagram shows how the strategies help us to achieve a net positive water design. Rainwater is collected in 3 ways. Firstly, collected from the rooftop, which is directly sent to the water tank. Secondly, softscape, which is sent to the recharge bed. Thirdly, hardscapes, which is used in the building after treatment. So use of all these strategies result in 3,290 kiloliters as water balance.
Coming to affordability, affordability is one of the vital for the sustainability and long-term cost effectiveness. So we have tried to look into financial feasibility of our design. So by considering affordability in perspective of long-term benefit, Team Vinaya designed safe, functional, well-equipped learning environment while optimizing the resources. To start with, the overall cost of the building is approximately 25% less than the base case. Now here we look into the civil work accounts for 22% of the total cost, which makes the per meter square cost approximately 12,600. Coming to where the material cost around 43 million INR, which largely include this IRCC, steel and building blocks, which contributes to around 77% of the construction materials. These materials have a high recycle content and also are produced with the less energy. Now, by designing, by effective space planning and effective architectural design practice, cost-effective locally material selection, we can develop an affordable building solution for next several years. Here, the payback period for the additional cost which we are applying for, which we are giving for PV is 3.8 years, whereas the solar water heater can be recovered in 1.8 years. Now, the overall cost of the building can be reduced by the use of carbon tiles, local material, refurbished furnitures, and also by using material with high recyclable content.
So, innovation. A smart building management system is proposed as an effort to engage students in the development of environmentally conscious and sustainable campus environment, which would have a positive impact on the psychology of students from a young age to use the resources consciously. In the system, a leaderboard displays the amount of energy use and waste generation in each class, resulting in healthy competition by real-time monitoring of energy, water, waste, and carbon emissions, data visualization, waste reduction techniques, gamification, community engagement, thus an innovative way to educate and implement green practices in the campus.
So now coming towards our last contest criteria, which is value proposition. Our aim is to inspire and encourage other school infrastructures to follow the similar path of the sustainability. Thus, Team Vinaya proposes, firstly, the net positive energy by implementing solar PV plant, a cost-effective and a sustainable solution, which is not only generates the significant amount of electricity annually, but also a substantial amount of savings of money annually after the initial investment is recovered. Secondly, the net positive water. Our total annual consumption is around 24,000 kiloliters annually. So out of these, we have annual surplus of around 3,000 kiloliters, which is treated grey water, which will be sent to the PMC tanker for the landscaping purposes, roadside landscaping purposes, and this creates a positive water infrastructure to our facility. Thirdly, the net zero waste. By converting organic waste into the manure, by adopting the policies of reduce, reuse, and recycle, and not sending the solid waste to the landfills. Fourthly, the green education campus rating by applying net zero strategies, which results in the green building certification. Hence, Team Vinay proposes a net positive campus design. Thank you.
Thank you, team. You all finished well in time. Let's hear it from the jurors now.
Hey guys, nice presentation.
Thank you, thank you.
And it's very clear, I think, in terms of the flow and the content that you had. I really like the architectural vocabulary of the spaces, the form finding and everything that you did. It's pretty interesting, but I still, but there are things that I think you left out in the presentation, which probably we could see. For instance, if you look at while you spoke about the form that is opened up, I mean, to capture the wind.
Yes.
So it wasn't really clear, I think, at least in the presentation that you said today, about the purpose of the windows that are, you opened it, right? I think you did not speak much about it. And how, I think in the CFD, you spoke about the airflow around the spaces, but what is it doing to the interiors? Like in terms of, the ventilation. So if I look at one module of a classroom, so this form, how is it impacting the airflow patterns and the cross ventilation, if at all you consider any of those?
Yes.
That did not come across in the presentation.
Okay.
So maybe you can talk about that. And also the roofs. I didn't understand the purpose, because you have a strong vocabulary. I mean, these ones that are there, which are like funnels that are on the top, which are again at a certain angle. So I was thinking that maybe you'll talk something about anything to do with the shape or the light or any of that. I think that's also not mentioned. Just trying to understand if there is any relevance to design at all, or it's just a feature.
So firstly, it's a feature actually. To coming for your second question, which is the roof form. So basically, for the we want to go towards a vernacular architecture. So we want to propose certain kind of a sloping roof kind of a system. So nextly, as the site lies in the warm and humid climate zone, so the staggered block arrangement and the spacing between two buildings is considered, and that's why instead of going for the flat roof system, because the buildings like academic blocks below behind that there is a Upasana Mandir structure, so that's why we have created sloping roof structures.
Got it. So there's nothing to do with the performance with this?
No.
Okay, so let's move back to the first question about the window openings that you did in the form. So yeah, on the airflow patterns.
So I'll just talk about each classroom. There is a wedge-shaped form is created for the academic block, and each classroom is designed such as to get west wind, which is the its annual wind direction is from the west. So each classroom gets the proper wind inside to the building. So, and the outlet will be from the overhangs, sorry. So the upper openings which are on the top, which will be, going out, like the hot air will be going out of the thing, and then the openings are such that the narrow openings are at the western side, and it will be getting open up into the courtyard. So the stack effect will create, and the school will be getting ventilated naturally. So that's the purpose.
Yeah, I mean, that's not did not come across in the presentation.
Yes.
But I have only one more thing before that, so I can pass on this thing. So you said that you overall, in terms of the affordability and all that, you managed to get it down by 25%. So what was the big move that helped you in actually getting that? Again, that's also not pretty clear.
So in the civil construction cost, the initial baseline was, we have planned a quota floor stone flooring for the interior spaces. But for the design case, we have come across the material which is carbon type. So it is very cost-effective solution, and it is towards a green material. So it made from the carbon. That's why we have designed the carbon tiles for the proposed case design, which will significantly reduce the amount in the civil works, the interior works.
I'm still not convinced, but I'll pass on the this thing, because how your carbon is, your tiles are actually reducing the cost by 25% of the overall
And
project
again,
cost.
yeah, so for the cement and for the reinforcement, we have used not a virgin materials we have used, and we have incorporated the recycled content material. So the cost, because the total built up is greater, so we need more amount of steel in the tonnage, and for the RCC purpose also, so the cement, so that cumulatively reduce the cost significantly because of using recycled content material, as it has a bit lesser amount than that of a virgin materials.
Can you maybe explain a bit about the composition of this carbon tile? What it is made up of?
Yeah, it's totally made up of carbon actually, which is generated from the nuclear power plants and the factory emissions, the carbon which is getting generated. So it's a newer material which is coming in the market. So it's a newer launch material.
Okay. And I just had a comment on your daylighting simulations. You have used the metric of daylight factor. So it's okay to use that, but I would recommend to probably move to more advanced metric, which is like UDI. There are many more. In fact, if you want to even go more advanced, you can use glare metric and all, but I think maybe you can gradually move to that. But daylight factor is a fairly kind of obsolete. I mean, it's few years back people used to predominantly use it, but not now.
Okay.
So consider moving into more better metric. In fact, daylighting also has lot of other ways how you can quantify the quality of light inside the space, right? So you can start thinking in those terms.
Yeah, sure.
Second is on your innovation part, you have mentioned about automation and the dashboard which you are creating. I probably wouldn't put that under an innovation category, because many buildings are now monitoring and showing their results, consumption, lighting, equipment. You can bifurcate it space wise. So now the buildings are more controlled, the facilities teams are also becoming more stronger, and these tools are widely available. But what sets this apart is the other points, the involvement that you're talking about, which is, let's say, the gamification part and the community engagement. That is where, that's lacking still right now. Most of our office buildings also where we work, all these things are monitored, but there is no communication to the end users. Like with us, the facilities team is doing that, but they are not passing it on to us. And we don't know how are the consumptions varying on a monthly basis. So that's where the catch is. Now you're saying that you will be gamifying the sustainable behavior, but maybe you need to elaborate more on how will you involve the students or the teachers, and how will you make the best use of it?
So that was the actual plan which you kindly mentioned. This is one part which can be obtained from any outsource agency also. The making some student, like the psychological changes which we are trying to implement at the small age itself, that is one of the innovation which we think, because if we are able to make them understand that this much is the energy and this much energy is which you are consuming is harming in this manner to your mother earth or somewhat, then we can make them understand also by trying some other, like creating a competitive environment among the different classes, so that if a class consumes less energy, so we were also thinking of can we have a kind of a green cup competition among the classes, so they have a this competitive environment to reduce their own energy consumptions.
No, I mean, as a thought, it's fine, but I just felt that it's not coming out very strongly and clearly right now. It's just written in a sentence, but it needs more thinking.
We accept that.
Team, thank you very much for your presentation. I also agree that it was quite clear, and kind of follows your report quite well. I think I'm going to pick up some of the questions which I had probably posed to you, and I had posed to you some questions, and I want to pick them up. One was this, thing about if you go to one of the plans, right, where you have a site plan. I think Monish also raised this question about, the chamfered shape, right, which allows the wind to access. So my question there was, do you have an image of, this block, like a render or something? Is it just a natural ventilated opening there, or do you have glass there? How does that work?
So for the classrooms, we have glazings, firstly glass, and also the mosquito nets also. So for the natural ventilation, they can just open the glasses and take the natural air in. So we have also incorporated the fins for the western and the southern facades, but not for the northern facades, because during the operational period, so there is no harsh glare on the northern facade. So for the southern and the western facades, we have incorporated the fins with the overhang. So that suffices the glare amount which is coming inside the building, and it also suffices the mosquito net, of course. It suffices the natural wind flow coming into the building, into the classrooms respectively.
So could you zoom into the plan somewhere where you can have that window which is facing towards the west, or the vent facing towards the west? Yeah, I think you had an isometric somewhere. Yeah. Yeah, so that one, that suffices actually. So the point I wanted to make was that, yeah, just if you leave it here, this good one. So you see the chamfered, walls, and next to it you have created these windows, which are actually now facing west, right? Because
yeah, all the windows which are, we are taking wind inside are the west facing windows.
yeah, but instead of glass, then you should just plan them as, louvers of some
we
kind.
have incorporated louvers for the western and the southern facades.
But you have windows there.
Windows with louvers and the overhang.
But that's the point I'm saying, that if you are creating a form that is for a certain purpose, you should make sure that you're not creating another issue, right? You are orienting your building north-south to avoid west. Then you chamfered it, and then you actually put glass on the west. And then you're saying, I'm going to put louvers to, allow some of it to come. So it overall looked like an interesting move, but when you resolved it in the detail, it stopped working. Right, so I think that idea of a chamfer is good, but you need to look at another way where you don't add a window there. It's either just louvers of smaller size. It will start working, and maybe you need to start looking at openings at few different levels, so that there is a buoyant flow that happens. Is there a site plan where I can understand where exactly are you putting the photovoltaic roof?
It's over the parking areas actually, and
You can just mention it. If you have a site plan, you can just tell me where you have planned it.
yeah, it's over the parking areas actually.
I mean, parking is on the ground? Like, is it this
So
on site?
this area is considered for the PV plant, and it's on the higher contour also, and there is no such huge vegetation, existing vegetation on the site. So we have considered the sun angles and all those things.
But this is an open,
Yes.
on ground
No,
parking.
no, it's
or is it a building?
raised. So the parking is ground, but the solar PV panels is on the top. So it's it will be the shaded parking area, and over that there
Right.
will be the
No,
peak.
why I was thinking was because of two reasons. Again, when you play with architectural form, the best thing would be that it should support your performance goals. So you created these interesting kind of, pyramidal roofs, but they actually take away all the area where you could have installed rooftop PVs, right? And then you had to really find place, and the next best one was parking. But then you also decided that you want to improve the performance of the PV, so you decided you'll go for bifacial PV. Now, bifacial PV works if the under surface of it is actually reflective, right? So you need to make it absolutely white so that it reflects the light, so the underside of the PV will also generate electricity. That's bifacial. But when you put it on a parking, you obviously have cars going up, down it. It's going to be dirty. You cannot achieve the performance of bifacial by putting it there. So I hope you're getting my point.
Yes,
That
absolutely.
you have made some interesting moves, but as soon as you get into the detail of it, you have not resolved it. This is another example. And but overall, I do see that you have a lot of control. Whatever you've done with significant control. I'll leave one last question. You can keep it short. I wanted to understand, if you open a typical plan of a classroom, and just tell me, how does the classroom operate on a monsoon day or a summer day, in Pune?
Yeah. So for the summer days, actually, considering the break time.
Can just open a plan so I can understand what windows you're opening, what's happening. So I imagine it's again not air conditioned, right? So classrooms are not air conditioned.
No, they are air conditioned, and
Okay.
labs are also air conditioned.
Okay,
The
then
academic
you
block
have
is
to
air
tell me.
conditioned. So firstly, the operational hours for the school are from 10 to 5, and the 1 to 2 is the break time. So we need a mechanical ventilation after 2 p.m. to 4 p.m. So in the peak summer times, and for the monsoon, as it's the humidity level rises, that's why we need air conditioning for the dehumidification inside the classrooms. So, and the set points were, consider 24 plus or minus 2 for the regularly occupied spaces like classrooms.
So I got a bit lost. Maybe I missed something here. In your report somewhere, I know 50% of your building.
Mhm.
Sorry, one third. About 33% of your building is air conditioned. Rest is not.
Firstly, in the deliverable 2, we haven't considered the classroom as the mechanically ventilated spaces. So after your comments, we have gone through the IMAC band, which is 90% IMAC band. And then we have, see that these 2 hours in the peak summer, like April. So for the May, it will be closed. The school will be closed. So we did simulation for the April month. And we have, analyzed that between 2 to 4, these are the non-comfortable hours for the naturally ventilated school. So we have incorporated the additional VRV system for the school classroom areas as well, along with the lab areas.
Okay. So those will operate only on the summer peak days.
Yes,
right?
and if there is a need in the monsoon for the dehumidification, so we will recommend it.
Okay. Now I get it. Because all right. Okay, that's it. Thank you very much.
Thank you, sir. Thank you, ma'am.
Thank you, jury members. Thank you, Team Vinaya. We'll take a 5-minute break and then continue with the next presentation. So the seventh and the final presentation is from Team Yukta. They have worked on a project called Lodha Codename, which is located in Thane district close to Mumbai. Their project partner is Lodha Group. Team, you will have 20 minutes to present your work to the jury. At 15 minutes, I will ring a signal. You won't have the next 21st minute, so please finish in time. We'll have a 10 minutes for the Q&A session. Please keep your answers direct and to the point. All the best, team. The stage is yours.
Good afternoon, everyone. This is Team Yukta. We are from Jawaharlal Nehru Architecture and Fine Arts University, and our team comprises of 12 students. And we work together for this Net Zero Building Challenge by Solar Decathlon India. Coming to the project partner, Lodha Group is a project partner, and we know that Lodha Group is a leading real estate developer in India. And coming to the location of the site is situated in Dombivli, Upper Thane, near Navi Mumbai. And the site is a part of larger development of a residential neighborhood. And coming to the context of the site, a 38-meter high multi-level car parking is being proposed towards the west direction of the site, and 72-meter high residential towers were towards the east direction, and 6-meter high retail stores were proposed towards the south direction of the site. Design process. After the SWOT analysis, the connectivity to the main road is one of the strengths of the site. But meanwhile, the site is located in a low-lying area near a river, which is a flood-prone area. And fly ash brick and bunclay bricks are the locally available materials. And the climate zone comes under the warm and humid type. And with the sky dome chart, we understood the requirement of shading devices in specific directions of the building, most probably in the south direction. And this is the CFD analysis just to understand the major wind direction, and it is from the west. And initially we came up with 6 different iterations. Later, on the basis of functionality, circulation, better lighting and ventilation, we have chosen the first one. And these are the few solar radiation analyses done to the 6 iterations. Coming to the 10 contests.
Architectural design. We have, the concept has evolved from a simple cuboidal form based on the built-up area and the ground coverage area requirements given by the project partner. So we have evolved the concept, the cuboidal form by removing the central block to have placed the central courtyard, which would provide natural ventilation and daylight to the entire building. And in the later stage, we have given the same central block to the front side, which provides a main entrance to the block. This is a site plan wherein the form has, we have evolved the form based on 3 major aspects. One is the orientation, one is the wind flow, and the central courtyard aesthetics. So also the orientation, the lengthiest side of the building is facing the north and south direction, wherein we have placed the classrooms, which receives constant daylight throughout the day. And towards the east direction, which receives maximum radiation, we have given the entrance, which is of double height, and also the administration block to the ground floor, which is more close to access. And also towards the west side, where we receive winds, we have given a double height multi-purpose hall, wherein we are letting in the winds flow inside the courtyard and to cool the building. And to segregate the traffic, we have given 3 access points. One is this for the vehicular movement, one for the pedestrian, one for the bus bay to avoid heavy traffic, and also to maintain safety and security of the children. And these are some of the views. This is the facade, the entrance, double height entrance, and this is the courtyard. And next. This is a sectional view which demonstrates the central,
this demonstrates the central courtyard and the double height multipurpose hall from where we are letting in the wind come in. And these are the different interior views of the classrooms which are designed based on the different age groups. And this is the ground floor where we have the pre-primary schools classrooms. And on the other levels, we have two standards having 5 sections each on all the floor plates. And on the topmost floor, we have a organic farming system, wherein along with it, we have outdoor classrooms and yoga space. And this one, it is a overhang canopy where it shades the building. This is the floor plan of the ground floor. This is the main access entrance to the building. Through this, we can access the administration block. And from here, we have this central courtyard, which can be accessed to the ramp. And these are the pre-primary classrooms and a double height multi-purpose hall. Also, this courtyard acts as a welcoming atmosphere. It creates a welcoming atmosphere as when you enter the building. This is a floor plan of the first floor, where we have 2 classrooms on the north and south direction, and 5 sections each, and the activity spaces which gain more radiation as it is facing the east direction. These are not oftenly used. Also, this is a 4th floor plan, 4th level.
So coming to the health and well-being part, we first studied the IMAC comfort charts to look at the times of the year when there is the times of the year which are most comfortable. So we found out that a temperature range between 24 degrees Celsius to 28 degrees Celsius is the comfortable part of the year. And dehumidification is also required for the type of climate. And we also studied the psychrometric chart, and we set a few targets for different seasons, the temperatures which we want to achieve in the spaces. And these are the results through the simulation we got. And this is for the classrooms from age 5 to 8. We observed that based on the ASHRAE 55-90% acceptability limits, so 90% of the classroom areas fall within the scale of -0.5 to +0.5 on the PMV scale. So this is considered to be like the neutral band. Similarly, we tried it out for the lecture classrooms as well. And during most part of the occupied time period, it falls under the comfort set points. We also then looked at the ventilation rates that would be required for different classrooms. And we calculated that for the air changes. And the air changes, we got around 4.31 air changes per hour for classrooms age 5 to 8. This graph shows a typical classroom, a nursery classroom. So most of the air changes values falls above the calculated value that we had seen. So for the HVAC system, we proposed an air-cooled VRF system, variable refrigerant flow with dedicated outdoor air conditioning systems. And we connected the outdoor units with using the supply and return ducts. To reduce the heat gain from the windows, we try to use solar control glass. And this graph shows us the temperature variations, and it can be observed that most part of the occupied time, it falls within the thermal comfort set point temperatures. For visual comfort, we looked at the useful daylight illuminance metric, and we found out that around more than 50% of the floor area, it falls under the, it has good useful daylight illuminance levels and for most part of the year. And it also is according to the ECBC plus compliance category. On the topmost floors, we have located the labs and other activity spaces, which receive a good amount of useful daylight illuminance, around 80 to 90% of the floor area. For the engineering and operations, we try to segregate the VRF systems in such a way that we have one outdoor unit for each floor. And coming to the structural system, we proposed an RCC structural system with shear walls for the staircase and the lift units. And then for the beams, we proposed two different types of beams, one the continuous beam and the simply supported beam. And we followed the IAS 456 standards for arriving at the final sizes of beams and columns. For solid waste management, we first try to look at the different types of waste generated in typical schools. And we proposed vermicomposting as a method to treat the waste. So this waste can also be used again for the organic farming which we had proposed on the topmost floor. The same composting can be used for that as well. And also the city of Mumbai has a waste segregation thing. And also our site, which is a part of a larger development, it also consists of waste segregation method. So we also proposed it for our school. And coming to the energy consumption, we tried out different strategies to reduce the EPI value. And we achieved a final EPI value of 45.07, which is below our target EPI of 55. And this is, on the left, we can see a breakdown of the different elements that contribute to energy consumption. We also did a comparison between HVAC system with it and without it, the energy consumption. These are again the areas considered for simulation and the end uses. For the building envelope, we tried to propose an AAC block wall, and we further optimized the envelope using an innovative facade, which reduced the U value further. And for the roof, we also thought of using XPS insulation to reduce the heat gain. And for the renewable energy system, we used solar panels of 465 watts.
Coming to the water performance, we have used several strategies and fixtures like faucet aerators and foam flush toilet, xeriscaping and sewage treatment plants to reduce the amount of water consuming. And this is the water supply flow in the building. Here we can see in detail like how the water flow from once collected from the rainwater from the rain, and it is collected to the underground water tank, and later it will be shifted to the overhead tank with the help of motor and the grey water, black water tanks in the underground. And by using these strategies, we have reduced it up to 55.32% of water consumption. And here we can see, as per NBC, the total requirement is 45 liter per person per day. Meanwhile, after the reduction, we got 20 liter per person per day. And this is the second table is the calculation of for the total users in the building. And because of using of Z-escaping, we even reduced the amount of water for the irrigation purpose. And this is the rainwater effective rainwater catchment area in the building, and that shows the total potential rainwater can be harvested during different months in a year. And this is the annual water consumption calculation chart for different months. And these are the water balance graph and water consumption graphs.
resilience. These are the risks and hazards the site has, and the major risk is coastal floods, and it has a medium earthquake risk, and the river floods are minute. And coming to the strategies we used, a plinth of 1.2 meters height has been used to overcome the flooding problem. And coming to the earthquake and wind resistance, we used a resist, and the whole building has been divided into 3 blocks where the column spans and beam spans are provided, and the momentum and shear force are under the limits where the building can resist the earthquake. Coming to the fire exit plan, we have 2 fire exits other than the main staircase, and we have 4 fire extinguishers at the fire exits. And coming to the service, we have a solar power inverter where we store the produced solar energy, and it can be used during the grid cutoff, and it can survive for 2 to 3 days, like working hours. And for coming to the food resilience, it can be achieved through organic farming. And coming to the water resilience, it can be achieved by for 20 days, like it can survive without grid. And affordability, uh, from the values we can comprehend that there is a 30% decrease in the proposed case. The main part is the usage of RCC construction has been resulted in a greater significant reduction in the total cost of the building. And the use of PT, that is a post-tension slab, which resulted in a decrease of slab height, like floor height, to by 0.6 meters. It resulted in a significant decrease in the cost and hard cost. And coming to the solar PV system, the total savings by installing a solar PV system is about 8 to 9 times that of the cost of installation or capital cost. And the savings in the operation of the building after the loan amount like can be repaid after that, it is significant.
Coming to the innovation part, we have proposed organic farming system on the terrace. The idea behind this is to create awareness and knowledge about nature and cultivation using traditional techniques of farming. In the current generation, the learning pedagogy in school is not practical, and also it is not encouraged to encourage learning in a natural setting. By proposing this innovation, we are trying to introduce these traditional techniques like the drip irrigation techniques using earthen pots on bottom of which we can put a hole and make the water flow drop by drop to the plants, and by teaching them by teaching them how to compost manure, and the rainwater harvesting techniques can help them learn and utilize not only in the school but also in their home and in the surrounding environment. This will create oxygen rich and chemical free environment not only in the school but also in their homes and the surrounding environment. Also, this can be practically executed because there's also a company named the Living Greens, which has come up with a technique of installing such systems on the rooftop and in the schools specifically. They can be scaled up and installed in the existing schools and universities as well.
Coming to the facade design, the facade is designed in such a way that to minimize the heat radiation inside the building, heat intake inside the building. At the same time, the live shell will be acting, helping to the deeper penetration of sunlight during the daytime. And these bricks are these are ad block bricks. It is made from the mixture of soil and compressing the soil and 6 to 9% of cement. And it is comparing to a conventional brick, it is 10 to 12 times lesser in carbon emission. And here we showed a sectional detail for it. And this is the blow up of the facade design.
So for another innovation, we looked at modular rainwater harvesting tanks. So these tanks are made out of recycled plastic material, and they also have a geotextile membrane covered on top of them to filter the water. And these tanks can receive water from either the rooftop or a softscape area, or there can be a planter bed also installed above them. And these can easily be placed in any part of the site as well.
Coming to the embodied carbon, lower carbon emission values have been achieved by using AAC blocks and earth clay blocks. Earth clay blocks have been used in the facade, which reduces heat gain and in the south, and we also provided bamboo screening in the top floor, where we have organic farming, which enables natural ventilation without harsh lighting. Okay, and these are the emissions from the wall lab. And there is a decrease of 62.5% in the proposed case.
Thank you, team.
This is the value proposition. And this shows our handmade model. It also shows a cybergraphy. Thank you.
Thank you. You did a great job. Let's hear the jury comments and take questions from them.
Hi, thank you for the presentation. And I have only one observation which I'm actually wanting to get some clarity on. Your building, the orientation, what you spoke about, the form finding, where you mentioned that you scooped out the block in the middle to convert that into a multi-purpose hall auditorium, right? So I was wondering, I mean, from the radiation perspective, and also you took the corridors in the middle towards the courtyard. But you haven't explained about the performance of the classrooms because what are the operational hours of the school?
Yeah, it's around 8 in the morning till 4 in the evening.
4 in the evening. So it's predominantly less of, I mean, you have all the 3 sites, radiation majorly from the south, but also because it's starting at 8, you'll have eastern sun, and also like slightly lesser towards the west, correct? But you'll still have the west sun, correct? So the classrooms, the way you position them, have you tried any other configuration where, because now all the classrooms which are on the east and the south are getting direct solar radiation, and you have done that, and then you're taking the corridor in the middle. So have you tried any other configuration wherein you are able to cut off the sun, maybe by positioning the corridors on that side and putting the classrooms towards to the courtyard or some other things, to see how the performance will change? So I mean, basically what I'm trying to ask is, how did analysis or this help you in your design? Can you explain more about your analytical approach towards design? How did it help you in design thinking? So that particular bit is not clear, because I'm trying to understand, if you go by without the tools, would you think something different than this, or this you came up with this form because you used the analysis?
So we have placed the classrooms on the north and south direction, which usually receives constant daylight throughout the day. And towards the east side, we have only placed like the spaces which are not oftenly used, like the dance activity spaces or computer labs or physical biology labs, like that. So even if it receives more radiation, it won't be much affected for the children, because they are not.
How can you conclude that? I'm trying to ask, like, how did you arrive at that conclusion, saying that
They are not, won't
affected?
be used.
Yeah.
So because because the classrooms, computer labs, only one class will be attending
See, I mean, we can keep arguing on the qualitative aspects throughout the day. So that's where the quantitative analysis come into play. So which is what I thought is missing in the presentation, because I can argue that it's not, you can say that it's good. I mean, everybody can have their own different kind of an opinion on this, right? but if you can prove it with the help of, I think that's the whole, that's what we are also looking for in the presentation, that, how did this quantitative analysis help you in arriving at a solution? So that particular bit, because that's what I thought. Would you have done it differently had you saw the, the metrics, so which I was not able to figure out in the presentation on the performance, and also the wind flow, especially because you've taken it, you did not speak much about you've taken a courtyard in the middle, right? And then you spoke about the west wind that is actually coming, where you gave the multipurpose hall, but the wind is only limited to that. What is the wind doing to the building, to the classrooms? Have you done anything to do with the cross ventilation? Do you have to do with adaptive thermal comfort, wherein you're actually using, certain parts of the day that you are air conditioning the spaces, and the rest of it you're using natural ventilation, because you are based out of, the whole project is based in Mumbai, right? So the humidity values are really high. So what are you doing about that? So these kind of questions, I believe, I personally, if you can explain on those lines.
So, for the initial iterations that we had tried out, we mainly looked at few key aspects that we wanted to focus on in the design. So based on that, we had designed the iterations. But later on, we also did a few solar radiation simulations for the same. And we didn't find much of a difference between most of the iterations, because the classrooms which were facing on the southern side definitely receive radiation. And so we only considered that aspect for the iterations. And secondly, for the classrooms, we in Design Builder, we simulated the system with a mixed mode of operation. So we used HVAC system as well as natural ventilation for the period of time. Yeah.
You also did mention about the facade treatment that you did based on the shading device, right? Can you actually go to that slide, please? Can you talk about that?
This one, sir. Yeah. So as we know, as we put the almost all classrooms toward the south direction, we're getting radiation. But the thing is like solar radiation. But the thing is like when we place it towards the south, during the simulation, we got around 90% of the amount of classroom is getting proper amount of sunlight. So meanwhile, for the low angle sun and in Mumbai, the 60 centimeter of chaja length is enough for the shading thing. So that's why we incorporated the louvers and the shading things.
Okay, so let me pass on the comment. So basically, these are my observations. I was thinking that qualitative, when you're talking about this, probably you were on the right direction. But had you been showing, the analysis to say that okay, this is how we arrived at it, it would have been much more convincing, I suppose. Okay. Thank you.
So I also had a question on this particular proposal that you're giving with this compressed stabilized earth blocks, right? Yeah. So the intent, even when I read your report, and I think the same thing you've also mentioned over here is the intention is to reduce the heat gains. This jali, if you look at the cross section, you are providing it towards the opaque part of the wall, right? Whereas the radiation or the heat that is coming through both the short wave, long wave radiation, it's coming through the glazing itself, right? What you're trying to cover over here is through these jalis, which could be, if I look at it from performance perspective, I don't think so it would be that impactful, to be honest. You can say that it is for aesthetics purpose or to kind of, add some sort of, you want to have like an exposed brickwork, jali brickwork. The architecture and aesthetics element is one part. But I don't see that in the text. What you're saying is performance, which I don't think would be that impactful, because if you are able, what you're essentially doing over here is you are cutting down the direct sun that will be hitting the wall, okay? Yes. Because if you look at the wall composition itself, which is AAC already has a very low U value. It's a very, it's a high performing material in itself. You are further creating a layer of air cavity and then a jali. So you're cutting down the radiation which is falling on the wall. This, I mean, effectively, in terms of the performances, you could have dealt with it maybe by using, maybe adding an insulation, or you would have maybe, I don't know, added high reflective paint. You also get pigmented paints now.
Yes.
They could have provided you a similar kind of performance. I'm speaking from heating performance only.
Yes,
Just correct me if you had a different thought in mind, because in terms of energy consumption, I don't think it is a very viable option.
Yes, ma'am. Like initially for this idea, we felt like comparing to a single brick wall, if we are doing a cavity wall, it will be more helpful for the reduction of the solar heat gain. So at the with that idea, we approach it to this instead of again creating a cavity wall. If we go with the brick treatment, then it will be also for the aesthetics in the same way. We'll be creating the cavity and helps in reducing the solar intake.
So this is a jali, right?
Yes, ma'am.
So it will have pores, it will have punctures, right? So cumulatively, there will be no still air. There is no air cavity which is there in between.
Okay.
So it will, I mean, that won't be a correct way to kind of calculate your overall U value. Because for the cumulative U value, the air needs to be still. Like that's how, or else in this kind of system, maybe in Design Builder, you need to simulate it quite differently, which I don't think you have done it.
Yes.
So that's one point. And also, I feel that you are probably over designing the system like this. If you look at it with respect to maybe the costing also, you could have, I think it would have been a very interesting exercise if you would have compared the effect of, the cumulative effect of using different assemblies, which is a simple AC block, B, you could have added an insulation, 3, you could have added like a high reflective paint, or which is pigmented, not like a bright white one. Many times it's not very, it creates a lot of glare. So you cannot apply it on vertical surfaces. But that kind of comparison, what are these material composition, how are they impacting your consumption versus how is it varying in terms of the cost? I think this could have been a very good like exercise for you to, so that based on that you can take an informed decision. Because right now it's not very clear in terms of creating this kind of assembly. And another point is on the indoor air quality. I think you also mentioned that you are bringing in natural ventilation in the classrooms, and that is improving your air quality. So you also need to pay attention to the external pollutants which are present in the air. And it's in Mumbai, so I'm sure the outdoor air is not going to be that clean.
Yes.
So would you be, like, how would you tackle that point?
So mostly we thought of ventilating the space using HVAC system only, because we were not able to meet the requirements using natural ventilation system. Like we were not able to achieve the air changes required using natural ventilation. So that's why we used the HVAC system. But using natural ventilation, we could improve the space by providing plants which make the indoor air more clean, which absorb the pollutants. So in that way, we can try to reduce the pollutants in the space.
I'm not very sure how much the plants help, but I mean, that's I think also an adequate filtration is needed in that case. If you are, because from your report it's not very clear if you are like conditioning all the spaces and you're providing adequate filters, but that's a point that you can consider.
So team, thank you very much for your presentation. I think just some quick reactions. I thought, from your report as well that you have developed certain thinking, and then you very quickly jumped into kind of justifying it in your mind without exploring, other options too much. So it became a little rigid in that sense, and you could have probably explored, the innovation side of it, architecture side of it, bit more, right? That would have added a lot of value. That's not to say that what you did is not good quality. It is just that you zoomed in quite fast, I feel, as against other teams. Would recommend that, even for this building, if you take it forward with your client, there are certain elements you should really kind of open out for, design development again. create options. So that's my reaction to that in general. What I wanted to ask you was, could you explain the mixed mode operation that you mentioned? How does that really work for a typical classroom? So because you have now an HVAC system, and but what are the controls and how do you manage it? In terms of different seasons and times of the day. Have you done some thinking on that?
So the mixed mode operation, whenever we are not able to meet the comfort set point temperature levels, or we are not able to achieve the air changes required, then because we are not able to achieve it through natural ventilation, we used HVAC system for it. But in mixed mode operation, what happens is the HVAC system is switched off, and the naturally ventilation thing is taking place. But in a mixed mode operation, both of them operate simultaneously. So there is infiltration also of air.
No, I didn't get that. Could you repeat the last bit? What's operating? Sorry? Just the last sentence you said. Was that?
Yeah, so during the mixed mode operation, both the naturally ventilation requirement and the HVAC system work simultaneously.
So in a classroom, are you thinking they can operate simultaneously?
Yeah, they can be operated.
Okay, so you're thinking the windows might be open.
Yeah, it can
and
be open.
to allow some natural ventilation, but then you are cooling through your VRV system. So, but your DOAS is off in that case. So, so the thing is this, that what you're telling me is roughly making sense, because see, when you put an HVAC system, obviously you have the flexibility of switching it on and off.
Yeah.
But that doesn't mean that you can really do it in real life. If you were sitting here, outside temperatures, okay, I open the window, I switch off one system, but keep the you need to work out the logic, right? So what I find is that you've gone for a very good conventional system, but you've not fully understood it. So what will be really great going forward is that you should pick up typical days and just study them. That do you think that in these hours, which system is switching on and off? Because systems also switching on and off, they should have some use for about at least an hour, right?
Yeah.
You will not switch them off for like half an hour and then switch it on for another 50. So that's one thing. So you'll find your energy consumption numbers majorly changing when you do those kind of calculations. That's one thought I have. Simultaneous working of natural ventilation and AC is quite complex to manage. So you need to have super, kind of smart kind of BMS system. You need to probably have windows that are not manually operated, but managed by some kind of mechanical system controlled by BMS. And so otherwise, have you thought about that? Is that in your report?
Yeah, we thought of a building automation system, but we thought it could be integrated with the VRF system itself.
Right. No, you have to think about it as a very specific thing. But there's another possibility that there could be certain areas of your building which are facing west, which actually go into air conditioned mode at some point, but there is another portion of the building which doesn't, on an end, because of radiation, right? So that kind of combination also needs to be studied, So that's again the missing piece. So what I felt is that quickly into a very good system, but not full understanding of that has been absorbed out of it. I really like the fact that you did try out making models, and with all the teams that really tried it out, I must tell you from all the jurors' side that it gave us a lot of insight into your thinking process and the building. It was so much faster for us to kind of understand. So well done on that. I hope in future teams will also continue doing that. That's about it actually from my side. Thank you very much.
Yeah, thank you.
Thank you, jury members. Thank you, Team Yukta. Folks, that was our last presentation in the Educational Building Division. Our esteemed jury panel has also shown immense dedication for assessing these entries. I want to thank the jury members for your thoughtful assessment and comments. And I want to congratulate all the finalists. As the jury coordinator for this division, I have had the opportunity to see these teams submit their deliverables. They have done some incredible work. Let us not forget that these teams have discovered a way to collaborate and do integrated design during the last 9 months. I think that itself deserves a round of applause. This evening, the jury members will meet and decide the winner and the runner-up teams. Let's see who will it be.